from the depths of the ocean to the vast reaches of space, and even some quirky corners of everyday life, these incredible truths are guaranteed to make you question everything you thought you knew. So sit back, relax, and prepare to be amazed, because truth really is stranger than fiction.
Seahorses are marine creatures known for their unusual reproductive role reversal. Unlike most species, male seahorses carry and give birth to their young. This remarkable phenomenon occurs in all 46 recognized species of seahorses, making them one of the few animals where males experience pregnancy. The male seahorse has a specialized brood pouch located on its abdomen. During mating, the female deposits her eggs into this pouch through an ovipositor. The male then fertilizes the eggs internally, providing a safe and controlled environment for the developing embryos. The brood pouch regulates factors such as salinity and oxygen levels, mimicking natural sea conditions to ensure the embryo's survival. Depending on the species, male seahorses can carry anywhere from a few dozen to over 1,000 eggs at a time. The gestation period typically lasts between 10 and 25 days, influenced by environmental conditions like water temperature. When the young are ready to hatch, the male seahorse undergoes labor, which involves rhythmic contractions to release the fully formed baby seahorses, known as fry, into the water. This role reversal offers significant advantages for seahorse populations. By sharing the reproductive burden, males enable females to produce another clutch of eggs while the male is pregnant, potentially increasing reproductive output. This strategy also allows for better protection and care of the offspring, as the male can shield the developing embryos from predators and environmental stressors within the brood pouch. Male pregnancy in seahorses is a unique adaptation that underscores the diversity of reproductive strategies in the animal kingdom. It challenges traditional notions of gender roles in reproduction and provides scientists with valuable insights into evolutionary biology. The phenomenon also highlights the importance of conserving seahorse habitats, as their populations are threatened by overfishing, habitat loss, and the global aquarium trade. Seahorses are monogamous during the breeding season, often engaging in elaborate courtship rituals, including synchronized swimming and tail-curling displays. These behaviors not only strengthen pair bonds, but also play a role in the transfer of eggs during reproduction. In summary, the male seahorse's ability to carry and give birth to offspring is a fascinating example of nature's ingenuity, showcasing a role reversal that is as practical as it is extraordinary.
Cows are social animals with complex emotional and social structures, and research has revealed that they are capable of forming strong bonds with specific individuals within their herd. These close friendships, sometimes referred to as cow best friends, reflect the animal's need for companionship and their capacity for emotional depth. Studies have shown that cows prefer the company of certain herd mates and will spend more time grazing, resting, or grooming alongside their chosen companions. When cows are separated from their best friends, they exhibit clear signs of distress. This stress manifests in various ways, such as increased heart rates, vocalizations, and restlessness. Prolonged separation from their preferred companions can even lead to behavioral changes, such as reduced appetite or withdrawal, which can negatively affect their overall well-being. The ability of cows to form strong social bonds highlights their emotional intelligence and capacity for empathy. This knowledge has important implications for animal welfare, particularly in farming and husbandry practices. Providing cows with opportunities to maintain their preferred social bonds and minimizing stress-inducing separations can improve their quality of life and overall productivity. It also challenges the traditional view of cows as solely utilitarian animals, underscoring the importance of treating them with care and respect.
Elephants are often noted as being the only animals that cannot jump, a characteristic that sets them apart from most other land mammals. This inability is primarily due to their immense size and unique physical structure. Elephants can weigh between 2,000 and 14,000 pounds depending on the species, and their sheer mass makes jumping biomechanically impossible. Unlike smaller animals, elephants' legs are not designed for the rapid flexion and extension required to propel their bodies off the ground. Their legs function more like pillars, providing stability and support for their heavy bodies. Each leg is equipped with strong column-like bones that are positioned directly beneath their torso, allowing them to bear enormous weight while walking or standing. However, this arrangement limits the range of motion in their joints, particularly the ankles and knees, which are essential for jumping in other animals. Additionally, elephants lack the elastic tendons found in the hind limbs of jumping animals, such as kangaroos or frogs, which store and release energy during a jump. Interestingly, while elephants cannot jump, they are still incredibly agile for their size. They can walk, trot, and even run at speeds of up to 25 miles per hour, although their run is more of a fast shuffle. Despite this, at no point during their movement do all 4 feet leave the ground simultaneously, as would happen in a true jump. This unique trait also has evolutionary advantages. Elephants evolved to rely on their massive size and strength for protection rather than speed or agility. Their inability to jump is less a disadvantage and more a reflection of their specialized adaptations for a large, slow-moving herbivore lifestyle. Understanding this limitation emphasizes the remarkable ways in which animals are tailored to their environments and roles in the ecosystem.
Kangaroos are uniquely adapted for forward movement and are unable to walk backward, a limitation rooted in their anatomy and specialized method of locomotion. This characteristic is largely due to the structure of their hind legs and their large muscular tails, which are designed for hopping and balance rather than versatility in movement. A kangaroo's hind legs are incredibly powerful and highly adapted for their signature mode of locomotion, hopping or saltation. These legs move in tandem and the joints and muscles are optimized for generating forward propulsion. However, this design sacrifices the flexibility needed for backward movement. Kangaroos' legs cannot move independently in the way that most other quadrupedal animals can, further restricting their range of motion. The tail of a kangaroo also plays a significant role in preventing backward movement. It acts as a counterbalance during hopping and as a support when the kangaroo is stationary or moving slowly. When a kangaroo is standing, its tail rests on the ground, effectively blocking backward steps. The tail, combined with the unique alignment of their hind legs, makes it physically challenging for kangaroos to move in reverse. Interestingly, this limitation has minimal impact on a kangaroo's survival. Their forward-focused design is ideal for covering long distances efficiently and quickly, allowing them to escape predators and search for food in the vast Australian landscapes they inhabit. Their inability to walk backward is more of a quirk than a disadvantage, highlighting the specific adaptations that have enabled kangaroos to thrive in their environment. The fact that kangaroos can't walk backward is also why they are one of the 2 animals, along with the emu, featured on Australia's coat of arms. These animals symbolize progress and forward momentum, reflecting the national ethos of moving forward.
Penguins are well known for their adorable courtship behaviors, and one of the most endearing rituals involves presenting a pebble to a prospective mate. This behavior is most commonly observed in species like the Adelie and Gentoo penguins. The act of offering a pebble is symbolic, akin to a proposal, and plays a crucial role in the bonding process and nest building. For these penguins, pebbles are highly valued as they are used to construct nests that protect their eggs from cold ground and potential flooding. During courtship, a male penguin will search for the perfect pebble, smooth, clean, and of the right size, and present it to a female. If she accepts the pebble, it signifies that she is receptive to forming a pair bond. This mutual exchange fosters trust and solidifies their partnership for the breeding season, as many penguins are monogamous and will stay with the same mate for years. The process of finding the right pebble is no small task. In some colonies, pebbles can be scarce, leading to competition among males. Some penguins are even known to steal pebbles from other nests when resources are limited. However, the male's effort to find and present a pebble is a significant part of showing his dedication and suitability as a mate. This ritual highlights the importance of both practicality and affection in penguin relationships. While the pebble serves a functional purpose in nest building, The act of giving it is a tender gesture that demonstrates the male's commitment to the female and their future offspring. The behavior underscores the complex social and emotional lives of penguins, making them one of the most fascinating bird species in the animal kingdom.
A group of porcupines is charmingly called a prickle, a term that aptly describes their most distinctive feature, their quills. Porcupines are solitary animals for most of their lives, but they occasionally form small groups, particularly during mating season or in regions where food resources are concentrated. When they do gather, the term prickle humorously captures both their physical appearance and the potential danger posed by their sharp, spiny defenses. Porcupines are covered in quills, specialized hardened hairs coated with keratin, that serve as their primary defense mechanism. When threatened, porcupines can raise and rattle their quills to deter predators. Although they cannot shoot their quills as is often believed, the quills detach easily upon contact and can embed in an attacker, making the animal's collective presence in a prickle particularly intimidating. The social dynamics within a prickle vary by species. Some species, like the North American porcupine, are more solitary, while others, such as certain Old World porcupines, display more social tendencies and may den in small groups. In these cases, being part of a prickle offers advantages like shared warmth and protection from predators. The whimsical term prickle is a part of the broader tradition of unique and often poetic collective nouns for animal groups. It reflects human fascination with the natural world and our tendency to describe animal behaviors and traits in creative ways. While porcupines are not the most social creatures, the idea of a prickle of porcupines evokes both the humor and ingenuity of language, as well as the respect for the remarkable adaptations of these spiky mammals.
Axolotls, sometimes referred to as Mexican walking fish, are extraordinary amphibians known for their remarkable regenerative abilities. Native to lakes near Mexico City, axolotls have the unique capability to regrow lost body parts, including their limbs, spinal cord, heart, tail, and even sections of their brain. This ability sets them apart from most vertebrates and has made them a subject of fascination in scientific research. The regenerative process in axolotls is incredibly efficient and precise. When an axolotl loses a limb or suffers tissue damage, specialized cells near the injury site revert to a less specialized state resembling stem cells. These cells then proliferate and differentiate into the exact types of tissues needed to rebuild the lost structure. Unlike scar tissue formation in humans, the regenerated limb or organ in axolotls is fully functional and often indistinguishable from the original. Axolotls can regenerate more than just external body parts. They are capable of repairing internal organs, including their heart and lungs, and can even regenerate parts of their central nervous system. For example, if part of their spinal cord is damaged, they can restore its functionality, which is a feat unmatched in humans. Similarly, axolotls can regenerate sections of their brain, offering a glimpse into their astonishing neuroplasticity. This regenerative ability has significant implications for science and medicine. Researchers study axolotls to better understand the cellular and molecular mechanisms underlying regeneration, hoping to apply these findings to human medicine. Insights from axolotl research could pave the way for advancements in treating spinal cord injuries, degenerative diseases, and organ damage. The axolotl's regeneration is not just a scientific marvel, but also a critical survival trait in their natural habitat. As a predator and prey species, their ability to recover from injuries enhances their resilience in the wild. However, despite their unique abilities, axolotls are critically endangered in their native environment due to habitat loss and pollution. Conservation efforts aim to protect these incredible creatures and ensure their survival both in the wild and as a vital resource for scientific discovery.
Starfish, or sea stars, have a fascinating and highly specialized feeding mechanism that allows them to turn their stomachs inside out to consume their prey. This unique adaptation is primarily used to feed on bivalve mollusks, such as clams and mussels, which are otherwise difficult to access due to their hard shells. The feeding process begins when a starfish uses its strong tube-like feet, powered by a water vascular system, to pry open the shell of its prey, creating a small gap. Once the shell is slightly ajar, the starfish everts its stomach, pushing it out through its mouth and into the prey's shell. This external stomach then releases digestive enzymes to break down the soft tissues of the prey, effectively liquefying it. The starfish absorbs the nutrients directly through its stomach lining, after which it retracts the stomach back into its body. This ability to evert its stomach allows the starfish to consume prey much larger than what its small central mouth would otherwise accommodate. It also minimizes the need for strong, crushing jaws, a feature many other predators rely on. The process is highly efficient and enables the starfish to thrive in environments where other predators might struggle to access similar food sources. Starfish play a crucial role in marine ecosystems as both predators and prey. By feeding on bivalves and other invertebrates, they help maintain the balance of these populations, preventing overgrowth that could disrupt the ecosystem. Their remarkable feeding mechanism underscores their evolutionary success and adaptability. This behavior is not only a marvel of biology, but also a reminder of the diversity and ingenuity of life in the ocean. The ability to turn their stomachs inside out showcases how starfish have evolved highly specialized traits to survive and thrive in their unique ecological niches.
Horses are unique among mammals in that they cannot vomit, a limitation rooted in their anatomy and physiology. This inability is due to the structure of their digestive system, particularly the powerful lower esophageal sphincter, also known as the cardiac sphincter. This muscular valve connects the esophagus to the stomach and is designed to prevent food and stomach acid from flowing backward. In horses, the lower esophageal sphincter is exceptionally strong and one-way, meaning it effectively seals the stomach once food enters, preventing regurgitation or vomiting. Additionally, a horse's stomach is relatively small and positioned deep within the rib cage, making the mechanics of vomiting nearly impossible. The angle at which the esophagus connects to the stomach further reinforces this one-way system. Unlike in other animals, the stomach muscles in horses are not designed to contract forcefully in reverse, which is necessary for vomiting. While this design helps prevent aspiration of stomach contents and allows horses to graze continuously without risk of reflux, it also presents significant risks. If a horse ingests something toxic, develops a gastrointestinal blockage, or suffers from severe colic, it cannot relieve the pressure or expel harmful substances by vomiting. This inability can lead to serious complications, such as stomach rupture, which is often fatal. Because horses cannot vomit, their digestive health requires careful management. Horse owners must ensure their animals have access to appropriate feed, avoid sudden dietary changes, and monitor for signs of colic or discomfort. Preventative care, such as regular dental checkups and deworming, also plays a vital role in maintaining their well-being. The horse's inability to vomit is an evolutionary adaptation that reflects its grazing lifestyle. However, it also underscores the importance of responsible care to minimize the risks associated with this anatomical limitation.
Ants are remarkable creatures with fascinating behaviors, and one of their lesser-known habits is their tendency to stretch and yawn when they wake up. While these actions might resemble human stretching and yawning, they are better understood as part of the ants' natural way of preparing their bodies for activity after a period of rest. Ants, like most insects, operate on a cyclical rhythm of activity and rest. During their rest periods, which are short and frequent rather than prolonged like human sleep, their bodies enter a state of reduced activity to conserve energy. These movements may involve extending their legs and antennae, which could serve multiple purposes, reactivating their muscles, enhancing their sensory perception, and ensuring their limbs and appendages are fully functional for the tasks ahead. The yawning behavior sometimes observed in ants is not a true yawn in the human sense, as ants do not breathe through their mouths. Instead, it is likely an opening and closing of their mandibles, possibly to clean or realign them, or to prepare for communication or foraging. Ants rely heavily on their mandibles for various activities, including feeding, carrying objects, and defending their colony, so ensuring their readiness is crucial. These behaviors are part of the ants' efficient and highly organized approach to colony life. Each individual ant plays a specific role, and even seemingly small actions like stretching and yawning contribute to their ability to perform tasks effectively. Observing these behaviors provides insight into how ants maintain their physical readiness and adapt to their demanding cooperative lifestyles. While these behaviors may seem simple, they underscore the complexity and adaptability of ants as social insects. Their ability to prepare themselves physically for activity after rest reflects the intricate balance of work and rest required to sustain the colony's productivity and survival.
The oldest known "your mum" joke dates back over 3,500 years to ancient Babylon, proving that humor rooted in playful insults has been a part of human culture for millennia. This joke is recorded on a tablet discovered in Iraq and is part of a collection of riddles and proverbs written in the Akkadian language, the lingua franca of the time. The tablet, dated to around 1500 BCE, is incomplete and heavily eroded, but enough survives to identify it as a humorous quip. The joke, as reconstructed by scholars, is an example of a yo mama insult. While the full context and exact wording have been lost due to the tablet's condition, the structure indicates it was meant to tease or provoke laughter, likely in a social or communal setting. The existence of this joke highlights how humor, especially of the irreverent and teasing variety, transcends time and cultural boundaries. It also provides insight into the everyday lives of ancient Mesopotamians, showing that humor was as integral to their lives as it is to ours today. This discovery is significant not only for its comedic value, but also for what it reveals about the continuity of human expression. The use of familial relationships as a basis for humor underscores a universal trait, the ability to laugh at shared social experiences. Even thousands of years ago, people found amusement in the playful and exaggerated lampooning of common subjects, such as family dynamics. Though the specifics of this Babylonian joke might be obscure, its existence as the oldest recorded "your mum" joke connects us to our distant ancestors in a surprisingly relatable way. It reminds us that while civilizations rise and fall, certain aspects of human nature, like humor, remain remarkably consistent.
The shortest war in recorded history took place on August 27, 1896, between the British Empire and the Sultanate of Zanzibar. This conflict, known as the Anglo-Zanzibar War, lasted a mere 38 minutes from the start of hostilities to the surrender of Zanzibar. The war arose due to a succession crisis in Zanzibar and the enforcement of British imperial interests in the region. Zanzibar, a small island off the coast of East Africa, was a strategically important territory for trade and British influence in the late 19th century. In 1890, the British and Germans signed the Heligoland-Zanzibar Treaty, making Zanzibar a British protectorate. When Sultan Hamad bin Thuwaini, a British ally, died suddenly on August 25, 1896, his successor, Sultan Khalid bin Bargash, took power without British approval. Khalid was perceived as hostile to British interests, particularly regarding their stance against the slave trade, which he supported. The British demanded that Khalid abdicate and proposed a more cooperative leader, Hamud bin Muhammad, as the new sultan. Khalid refused and fortified the palace with his supporters and artillery, setting the stage for conflict. At 9:02 a.m. on August 27, 1896, after the expiry of an ultimatum given to Khalid, British warships in the harbour opened fire on the palace. The bombardment was devastating. Within minutes, most of Khalid's defences were destroyed, and the palace suffered significant damage. Zanzibari forces, numbering around 2,800, were outmatched by the superior firepower of the British fleet. By 9:40 a.m., Khalid's forces had surrendered, marking the end of the war. Zanzibari casualties were reported to be around 500, while the British sustained only one minor injury. Sultan Khalid fled to the German consulate, where he was given asylum. He was later captured and exiled, while the British installed Sultan Hamud bin Muhammad as their preferred ruler. The war solidified British control over Zanzibar and demonstrated the might of British naval power during the height of its empire. It also served as a stark example of the disparity in military technology and organization between colonial powers and smaller states. Sultan Hamud, the new ruler, complied with British demands, including the abolition of the slave trade. The Anglo-Zanzibar War is remembered not only for its brevity, but also as a symbol of the imperial dominance of the British Empire. It highlights the rapid and often overwhelming force used by colonial powers to maintain control over their territories. Despite its short duration, the war is a fascinating historical footnote, illustrating the dynamics of imperialism, local resistance, and geopolitical maneuvering in the late 19th century.
Genghis Khan's conquests in the 13th century were so devastating that they had an unintended environmental impact. They temporarily reduced global carbon dioxide levels. This phenomenon, often called the Genghis Khan effect, occurred because the Mongol invasions caused widespread destruction, depopulation, and the abandonment of agricultural land, leading to large-scale reforestation and the absorption of carbon dioxide from the atmosphere. Genghis Khan, who lived from 1162 to 1227, was the founder of the Mongol Empire. He led a series of campaigns that created the largest contiguous empire in history, stretching from East Asia to Eastern Europe. These conquests resulted in the deaths of an estimated 40 million people, or about 10% of the world's population at the time. Entire cities and civilizations were razed, and agricultural systems were disrupted across vast regions. The mass depopulation caused by the Mongol invasions had significant ecological consequences. With fewer people to tend farmland, vast tracts of cultivated land were abandoned and reverted to natural forests. This reforestation acted as a carbon sink, absorbing large amounts of carbon dioxide from the atmosphere. Researchers estimate that up to 700 million tons of carbon dioxide were removed during this period, an amount roughly equivalent to a year's worth of global gasoline consumption today. Forests play a crucial role in regulating the Earth's carbon cycle. When farmland is abandoned, natural vegetation regenerates and forests absorb carbon dioxide through photosynthesis. The reforested areas that emerged after the Mongol invasions likely covered millions of acres, especially in parts of Asia and Europe. This reduction in atmospheric carbon dioxide likely contributed to a slight cooling of the Earth's climate, though other factors such as volcanic activity and solar variations also influence medieval climate patterns. This phenomenon is one of several instances in history where human activity, or its cessation, has influenced the Earth's carbon balance. Other examples include the depopulation of the Americas following European colonization and the subsequent reforestation, as well as industrial deforestation in more recent centuries. The Genghis Khan effect is unique in that it underscores the unintended environmental impact of large-scale violence and conquest. While the temporary cooling effect caused by the Mongol Empire's conquests may seem like a historical footnote, it highlights the interconnectedness of human activity and the environment. It serves as a stark reminder of how societal collapses, whether due to war, disease, or other factors, can have lasting ecological effects. The Mongol Empire's conquest left a legacy not only in terms of geopolitics and culture, but also in the planet's ecological history.
The first oranges weren't orange, they were green. This surprising fact highlights the diversity of citrus fruits and their adaptations to different climates. Oranges, specifically the original sweet varieties, originated in Southeast Asia, particularly in regions such as modern-day India, Vietnam and southern China. These early oranges were likely green when ripe, a trait that persists in certain climates to this day. The color of an orange's peel depends on its environment, particularly temperature. In tropical and subtropical climates, oranges often remain green when ripe because the constant warmth prevents the breakdown of chlorophyll in the peel. Chlorophyll is the pigment that gives plants their green color. In cooler climates, however, the lower temperatures during ripening trigger the breakdown of chlorophyll, allowing the orange carotenoid pigments to dominate and giving the fruit its characteristic bright orange colour. The first oranges, varieties like the pomelo and mandarin, which are the ancestors of modern sweet oranges, developed in consistently warm climates where the green colour persisted even at full ripeness. Even today, green oranges are common in tropical regions such as Thailand, Vietnam, and parts of Central America. These oranges are fully ripe and just as sweet as their orange-coloured counterparts. In fact, in these regions, an orange peel's colour is not considered an indicator of ripeness. Consumers judge ripeness by other factors, such as the fruit's aroma and texture. In contrast, oranges grown in temperate regions, such as the United States and parts of Europe, turn orange due to cooler autumn and winter temperatures. In some cases, producers in tropical areas artificially remove the green coloration by exposing the fruit to ethylene gas or refrigerating it to mimic cooler climates, making them more appealing to markets where consumers expect oranges to be, well, orange. The green to orange transformation also has cultural and linguistic implications. The English word orange comes from the Old French term orange, which itself was derived from the Sanskrit word naranga through Persian and Arabic. This linguistic journey reflects the fruit's movement along ancient trade routes, but the association of the word with the colour only became solidified in Europe, where oranges ripened to a vivid orange hue. Understanding the history of green oranges provides insight into the evolution of agriculture, trade and human preferences. It also underscores the importance of climate and environment in shaping the characteristics of crops. While most of us are accustomed to bright orange fruits, green oranges serve as a reminder of the rich variety within nature and the adaptability of plants to their surroundings.
After Albert Einstein's death on April 18, 1955, his brain was removed without permission, setting off a decades-long saga of controversy and scientific inquiry. Einstein, one of history's most renowned physicists, had revolutionized our understanding of the universe with his theories of relativity. His intellect fascinated scientists and the public alike, and this fascination extended beyond his life, leading to the illicit preservation and study of his brain. Einstein died of an abdominal aortic aneurysm in Princeton, New Jersey at the age of 76. During his autopsy, conducted by pathologist Dr. Thomas Harvey at Princeton Hospital, Harvey removed Einstein's brain without the permission of his family. Harvey reportedly justified this act by claiming it was for scientific research, believing that studying the brain of such a brilliant mind could unlock the secrets of genius. Einstein had explicitly stated in his will that he wanted to be cremated and his remains scattered, and he made no mention of donating his brain to science. Despite this, Harvey took the brain, along with Einstein's eyes, which were given to Einstein's ophthalmologist. Harvey preserved Einstein's brain in formalin and divided it into 240 blocks. He also made over 1,000 microscopic slides of brain tissue for analysis. He kept these samples for decades, distributing them to researchers worldwide for study. Over the years, various scientists examined the brain, hoping to uncover physical correlates of Einstein's exceptional intellect. Some studies claim to find differences in Einstein's brain structure. For example, in 1985, a study suggested that Einstein had an unusually high number of glial cells, which support and nourish neurons in certain parts of his brain. In 1999, researchers reported that his parietal lobes, associated with spatial reasoning and mathematical ability, were unusually large and lacked a typical groove, potentially enhancing connectivity. These findings were widely publicized but remain controversial. Critics argue that the studies were poorly controlled and relied on limited anecdotal comparisons. Moreover, the ethics of studying Einstein's brain, removed and preserved without his consent, cast a shadow over the entire endeavor. The unauthorized removal of Einstein's brain had significant consequences for Dr. Harvey. After Einstein's family learned about the incident, his son Hans Albert Einstein was initially furious, but eventually granted Harvey permission to keep the brain, provided it was used only for scientific research. However, Harvey's career suffered. He lost his job at Princeton Hospital and spent the rest of his life moving from place to place, taking Einstein's brain with him. Harvey eventually returned the remaining pieces of the brain to Princeton Hospital in 1998. Today, some of these samples are stored at the Mutter Museum in Philadelphia, where they are occasionally displayed. The story of Einstein's brain raises profound ethical questions about consent, privacy, and the treatment of human remains. While the studies conducted on his brain have yielded intriguing insights, they have not provided definitive answers about the biological basis of genius. Einstein's legacy as a physicist and humanitarian far overshadows the controversy surrounding his brain, but the episode serves as a cautionary tale about the boundaries of scientific curiosity and respect for individual autonomy.
In the summer of 1518, the city of Strasbourg, then part of the Holy Roman Empire, now in modern-day France, was gripped by a bizarre and inexplicable event known as the Dancing Plague. Over the course of several weeks, dozens of people were afflicted with an uncontrollable compulsion to dance, sometimes to the point of exhaustion or death. This phenomenon remains one of the most mysterious mass hysteria events in history. The Dancing Plague began in July 1518 when a woman named Frau Trophea stepped into the streets of Strasbourg and began to dance fervently. She appeared unable to stop, continuing for hours and then days. Within a week, her strange behavior had attracted dozens of others who joined her in a similarly uncontrollable dance. Reports suggest that as many as 400 people eventually became part of the epidemic. The dancers were not performing joyful or celebratory movements. They seemed to be in a trance-like state, moving erratically and sometimes crying or screaming. Many of them collapsed from exhaustion, and some reportedly died from heart attacks, strokes, or sheer fatigue. The cause of the dancing plague has baffled historians and scientists for centuries. Several theories have been proposed, including 1. Mass hysteria. The most widely accepted explanation is that the dancing plague was a case of mass psychogenic illness triggered by stress and fear. Strasbourg in 1518 was a time of hardship, marked by famine, disease, and economic instability. These pressures may have caused a collective psychological breakdown, manifesting as a hysterical dancing frenzy. 2. Ergot poisoning. Another theory posits that the afflicted individuals consume bread contaminated with ergot, a fungus that grows on damp rye and can produce hallucinations, convulsions, and other symptoms similar to those seen during the dancing plague. Ergot poisoning has been linked to other historical events, but it does not fully explain the prolonged and coordinated nature of the dancing. 3. Religious or superstitious beliefs. Some historians suggest that the event may have been linked to local religious beliefs. Saint Vitus, the patron saint of dancers, was believed to have the power to curse people with uncontrollable dancing. Fear of divine punishment could have played a role in the outbreak. 4. Social contagion. In tightly knit communities, behaviors can spread rapidly through imitation and suggestion. In a time of heightened stress and fear, witnessing others dance uncontrollably may have triggered similar responses in susceptible individuals. The local authorities initially believed that the afflicted could dance off their condition. They even hired musicians and built stages to facilitate the dancing, hoping it would bring about a cure. This strategy backfired as it seemed to exacerbate the problem, drawing more people into the frenzy. Eventually they turned to religious intervention, organizing prayers and processions to St. Vitus, and the epidemic subsided by September 1518. The dancing plague of 1518 is one of the most documented cases of a phenomenon known as dance mania, which was reported sporadically in Europe from the 14th to the 17th centuries. It remains an enduring mystery and a fascinating example of how psychological, social, and cultural factors can intersect to produce extraordinary collective behavior. The event also serves as a reminder of the power of societal stress and the human mind's capacity to manifest distress in physical and communal ways. While no definitive explanation exists, the dancing plague continues to capture the imagination of historians, psychologists, and artists alike.
The claim that Pope Gregory IV declared a war on cats in the 13th century is a popular anecdote, but it is not entirely accurate when viewed in historical context. The story stems from a papal decree or belief associated with Pope Gregory IV that linked cats, particularly black cats, with heresy and devil worship. This belief contributed to broader medieval superstitions, associating animals with witchcraft and the occult. In 1233, Pope Gregory VI, not Gregory IV, issued the Vox in Rama, a papal bull addressing the spread of heresy, specifically concerning a cult alleged to practice satanic rituals. The bull described ceremonies where a black cat was reportedly involved as a demonic symbol, further fueling anti-cat sentiment in the Christian world. The bull was part of broader measures to combat heretical movements in Europe, particularly in Germany. While Pope Gregory IX's text does not call for the extermination of cats explicitly, its content contributed to widespread suspicion of cats as accomplices in witchcraft. Over time, these ideas contributed to the persecution and killing of cats, especially black ones, across Europe. Cats were believed to be familiars of witches or even embodiments of the devil, leading to their association with evil. This superstitious fear culminated in mass culling of cats in various regions during the Middle Ages. Some historians suggest that the mass killing of cats may have had unintended consequences, such as enabling a rise in rodent populations, which could have exacerbated the spread of the Black Death in the 14th century. However, this connection remains speculative, as the plague's primary transmission vectors were fleas on rats, and the dynamics of disease transmission are complex. While Pope Gregory IX's Vox in Rama had significant cultural impacts, it is important to approach the story critically and recognize that the war on cats narrative has been exaggerated and simplified over time. It reflects a mixture of historical events, medieval superstitions, and later interpretations, rather than a straightforward declaration of a campaign against cats by the Church.
The Great Emu War of 1932 was a bizarre and often humorously recounted event in Australian history, in which the Australian military attempted to curb the population of emus, large, flightless birds native to the continent. This war occurred in the state of Western Australia and ended with the emus emerging as the clear victors, much to the embarrassment of the military forces involved. The conflict arose during a challenging period of Australian history, the Great Depression. Many unemployed veterans from World War I had been granted land in Western Australia for farming. However, these farmers faced significant hardships, including drought, low crop prices, and most notably, an invasion of emus. Around 20,000 emus migrated from inland regions to the agricultural areas, damaging crops and causing financial ruin for many farmers. In response to the farmers' pleas for assistance, the Australian government decided to intervene. Major GPW Meredith of the Royal Australian Artillery was dispatched with a small military force, equipped with 2 Lewis machine guns and 10,000 rounds of ammunition to address the emu problem. The campaign began in November 1932, but the emus quickly proved to be formidable opponents. The birds demonstrated remarkable speed, agility, and group cohesion, making them difficult targets. They traveled in large flocks, but often scattered in unpredictable directions when approached. The military faced numerous logistical challenges, including difficulties in maneuvering the heavy machine guns and hitting the fast-moving emus. One of the most infamous moments occurred when the soldiers attempted to ambush a group of emus near a dam. Despite firing on the birds, only a few were killed, and the rest scattered into the surrounding countryside. On another occasion, the military mounted a gun on a truck to chase the emus, but the rough terrain rendered the operation ineffective. After several weeks of effort, the operation was deemed a failure. Major Meredith's team had killed approximately 1,000 emus, far fewer than expected, and had expended a significant amount of ammunition. The emus, on the other hand, continued to roam the farmland largely unscathed, earning the unofficial victory in what became known as the Great Emu War. The Great Emu War highlighted the futility of using military tactics against nature and became a symbol of human ineptitude in the face of wildlife. The Australian government abandoned military interventions and later encouraged farmers to manage the emu population with fencing and other measures. Additionally, a bounty system was introduced, which proved more effective in controlling the birds. The event has since become a humorous anecdote and is often cited as an example of nature triumphing over human attempts at control. It remains a quirky and endearing chapter in Australian history, capturing the imagination of people worldwide.
The Leaning Tower of Pisa is one of the most famous architectural landmarks in the world, renowned for its unintended tilt. Construction of this iconic structure spanned 344 years, beginning in 1173 and concluding in 1319 for the main structure, with final completion, including the bell chamber in 1372. Its long construction period is a testament to the challenges posed by its unstable foundation and the technological limitations of the time. The tower was designed as a freestanding bell tower, or campanile, for the adjacent Pisa Cathedral, part of the city's Campo dei Miracoli, or Field of Miracles. The project began in 1173 under architect Bernardo Pisano, though his involvement remains debated. The first phase of construction lasted until 1178, when workers had completed the first 3 stories. During this early phase, the foundation began to sink due to the unstable subsoil composed of clay, sand and silt. This caused the tower to tilt noticeably to the south. Construction was halted not only due to the tilt, but also because of ongoing wars between Pisa and neighbouring city-states such as Florence and Genoa. This pause lasted nearly a century and ironically helped the tower survive, as the soil had time to settle. When construction resumed in 1272 under architect Giovanni di Simone, efforts were made to correct the tilt. Builders attempted to compensate by constructing the upper stories with one side taller than the other. This gave the tower its characteristic curved appearance as successive levels were adjusted to counteract the lean. However, the tilt continued to worsen as construction progressed. The main structure was completed in 1319, but the final addition, the bell chamber, was only added in 1372 by architect Tommaso di Andrea Pisano. The total time from the start to finish, considering interruptions, amounted to 344 years. The tilt of the Leaning Tower of Pisa became its defining characteristic and a source of fascination. Over the centuries, the lean gradually worsened, reaching a dangerous angle of 5.5 degrees by the 20th century. Efforts to stabilize the structure began in earnest in the late 20th century. Engineers employed innovative techniques, including soil extraction and counterweights, to reduce the tilt to a safer angle of about 4 degrees by 2001. The tower reopened to the public in 2001 after a decade-long stabilization project. The Leaning Tower of Pisa stands as a symbol of architectural ambition and resilience. Its unintended tilt has made it a global icon, drawing millions of tourists annually. It is a UNESCO World Heritage Site, celebrated for its historical and architectural significance alongside the cathedral and baptistry in the Field of Miracles. The tower's prolonged construction period and its subsequent lean serve as reminders of the complexities of medieval engineering and the unpredictable challenges of working with natural landscapes. Far from being a failure, the Leaning Tower of Pisa has become a triumph of preservation and a beloved emblem of human ingenuity.
The idea that people in the Victorian era sent letters using hollowed-out potatoes is a curious anecdote that captures the imagination, but it is more of a whimsical myth than a well-documented historical practice. While the Victorian era, from 1837 to 1901, was indeed a time of significant postal innovation, including the introduction of the penny post in 1840. The practice of sending unconventional items through the mail was generally rare and often limited by practicality and postal regulations. The Victorian period revolutionized mail delivery with advancements like affordable postage, the standardization of mailboxes, and the introduction of postmarks. The penny post allowed people to send letters anywhere within Britain for a penny, leading to a massive increase in correspondence. This era also saw the rise of the postcard, which became a popular and inexpensive way to send short messages. The idea of sending hollowed-out potatoes as a means of delivering letters seems to be more of a playful anecdote than a widespread historical practice. While it's not entirely implausible that someone might have attempted such a thing as a prank or novelty, there is no substantial evidence to suggest it was common or practical during the Victorian era. Sending a hollowed-out potato as a letter would have faced several obstacles. Potatoes are perishable and bulky, making them impractical for reliable delivery. Additionally, postal regulations of the time required items to be securely packaged and clearly addressed. While Victorian postmasters might have handled a variety of unusual items, it is unlikely they would have tolerated hollowed-out vegetables on a regular basis. The myth of potato mail fits within a broader fascination with quirky Victorian customs, many of which have been exaggerated or invented over time. The era's sense of humour, combined with the popularity of novelty items and elaborate practical jokes, may have contributed to the persistence of this story. While the story of Victorians sending letters in hollowed-out potatoes is entertaining, it is more likely a myth than a reflection of historical postal practices. The Victorian era was indeed a time of postal creativity, but its innovations were more focused on efficiency and accessibility than on vegetable-based correspondence.
The statement that all the planets in the solar system can fit side by side between Earth and the Moon is a fascinating astronomical fact, and it highlights the vastness of space even within our own celestial neighborhood. Here's how this works. The average distance between Earth and the Moon is about 384,400 kilometers, or 238,855 miles. This measurement, known as the lunar distance, varies slightly due to the Moon's elliptical orbit, but it is sufficient for this calculation. If we add up the equatorial diameters of all the planets in the solar system, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune, the total comes to approximately 364,900 kilometers, or 226,000 miles. Here's the breakdown. Mercury, 4,880 kilometers. Venus, 12,104 kilometers. Earth, 12,742 kilometers. Mars, 6,779 kilometers. Jupiter, 139,820 kilometers. Saturn, 116,460 kilometers. Uranus, 50,724 kilometers. Neptune, 49,244 kilometers. When these diameters are summed up, the total is slightly less than the average Earth-Moon distance, leaving some extra room even after accounting for all the planets lined up. The reason this fact is so surprising is due to the vast difference between planetary sizes and the immense distances in space. While planets like Jupiter and Saturn are massive compared to Earth, their diameters are minuscule when measured against the distances between celestial bodies. This serves as a reminder of the scale of the universe and how far apart objects in space truly are. This comparison is purely theoretical, since planets cannot align in a straight line in real life, let alone line up between Earth and the Moon. However, the fact serves as a thought-provoking exercise in understanding spatial relationships within our solar system and the surprising emptiness of space. The idea that all the planets could fit side by side between Earth and the Moon is a striking demonstration of the relative sizes and distances in our solar system. It's a testament to the vastness of space, even in what we often perceive as a relatively small part of the universe. This thought experiment not only fuels curiosity about astronomy, but also underscores the remarkable scales at play in our cosmic neighborhood.
The Mpemba effect is the counterintuitive phenomenon where, under certain conditions, hot water freezes faster than cold water. This effect has puzzled scientists and observers for centuries and remains a topic of ongoing debate and study in the field of physics. Named after Erasto Mpemba, a Tanzanian student who popularized it in the 1960s, the effect challenges our understanding of heat transfer and thermodynamics. The Mpemba effect has been noted by scholars throughout history. Aristotle in ancient Greece, Francis Bacon in the 17th century, and René Descartes all documented similar observations. However, the phenomenon was not rigorously studied until Mpemba, a high school student, observed that warm ice cream mix froze faster than a cold mix when placed in the freezer. This observation led to scientific investigations into the effect, which has since been named in his honor. Despite extensive research, the Mpemba effect is not fully understood and no single explanation has been universally accepted. Several hypotheses have been proposed, including 1. Evaporation. Hot water evaporates more quickly, reducing the volume of water that needs to freeze. This smaller volume may freeze faster than the larger volume of cold water. 2. Convection currents. Hot water may develop convection currents that accelerate the cooling process by distributing heat more evenly compared to cold water. 3. Dissolved gases. Hot water tends to release dissolved gases, which might alter its freezing point or thermal conductivity. 4. Supercooling differences. Cold water might supercool, dropping below its freezing point without solidifying more easily than hot water, delaying the freezing process. 5. Thermal conductivity of the container. The interaction between the water and the container might differ based on the initial temperature, influencing heat transfer rates. 6. Hydrogen bond dynamics. Some researchers have suggested that differences in hydrogen bonding and molecular structure between hot and cold water may play a role in the Mpemba effect. It's important to note that the Mpemba effect is not always observed. The phenomenon depends on various factors, including the initial temperatures of the water, the cooling environment, the type of container used, and the presence of impurities or dissolved gases in the water. Under certain conditions, cold water may freeze faster than hot water, as one would intuitively expect. The Mpemba effect remains controversial, with some scientists questioning whether it exists as a distinct phenomenon or if it is the result of specific experimental setups. Experimental results have been inconsistent, partly due to the difficulty of precisely controlling all variables. Recent studies using advanced techniques have added to the complexity of the discussion rather than resolving it. While the Mpemba effect is primarily a topic of scientific curiosity, understanding it could have practical implications for fields like cryogenics, refrigeration, and materials science. However, its real-world applications remain limited until a definitive explanation is found. The Mpemba effect is a fascinating reminder that nature often defies simple expectations. Though it challenges our understanding of basic principles like heat transfer, it also highlights the complexity of seemingly straightforward phenomena. The ongoing investigation into the effect underscores the importance of curiosity and observation in scientific discovery.
HD 189733b is one of the most extreme and fascinating exoplanets ever discovered. Located about 64.5 light-years from Earth in the constellation Vulpecula, this hot Jupiter is infamous for its hellish weather, which includes sideways rain of molten glass, due to ferocious winds and scorching temperatures. It serves as a vivid example of how alien and inhospitable worlds beyond our solar system can be. HD 189733b was discovered in 2005 using the transit method, where astronomers observe the dimming of a star's light caused by a planet passing in front of it. The planet is a gas giant similar in size to Jupiter, but it orbits its host star at an extremely close distance, just 4.7 million kilometers or 2.9 million miles. This proximity makes it a hot Jupiter, a class of exoplanets characterized by high temperatures and rapid orbits. HD 189733b completes one orbit around its star in just 2.2 Earth days. What makes HD 189733b particularly intriguing is its violent and bizarre weather, molten glass rain. The planet's atmosphere contains silicate particles, which condense into tiny glass droplets under extreme heat. These droplets form in the upper atmosphere and are carried by relentless winds. The glass rain reflects blue light, giving the planet a striking blue appearance when observed from a distance. Supersonic winds. Winds on HD 189733b reach speeds of up to 8,700 kilometers per hour or 5,400 miles per hour. These winds are so strong that they carry the molten glass rain sideways, making the weather even more extreme and chaotic. The planet's proximity to its host star results in surface temperatures of approximately 1,000 degrees Celsius or 1,832 degrees Fahrenheit. This intense heat drives the violent weather patterns and prevents the planet from being hospitable to any form of life as we know it. HD 189733b has been extensively studied using telescopes like the Hubble Space Telescope and the Spitzer Space Telescope. Observations of its atmosphere have provided valuable insights into the composition and behavior of exoplanetary atmospheres. For example, scientists have detected water vapor, methane and carbon monoxide in its atmosphere, along with the silicate particles responsible for the glass rain. The planet's vivid blue color, observed in 2013, contrasts with Earth's blue appearance, which is due to Rayleigh scattering in our atmosphere. On HD 189733b, the blue hue is caused by the reflective properties of the molten glass droplets. Despite significant advancements in exoplanet research, studying HD 189733b remains challenging due to its distance and the limitations of current technology. The extreme conditions on the planet also push the boundaries of atmospheric modeling and highlight the diversity of planetary systems in the universe. HD 189733b is a prime example of the extreme environments that exist beyond our solar system. Its study helps astronomers better understand the diversity of exoplanets and their weather systems, which in turn informs our search for habitable worlds and extraterrestrial life. HD 189733b is a mesmerizing and terrifying example of an alien world with weather unlike anything on Earth. From its sideways rain of molten glass to its supersonic winds and scorching heat, it offers a glimpse into the incredible variety of planets in the cosmos. Studying such extreme exoplanets not only deepens our understanding of planetary science, but also underscores the uniqueness of Earth as a haven for life.
Mercury, the smallest planet in our solar system and the one closest to the Sun, has a remarkably short year, just 88 Earth days. This means that Mercury completes an orbit around the Sun in less than 3 Earth months. The planet's short year is a result of its close proximity to the Sun and its rapid orbital speed, making it a fascinating subject of study in planetary science. Mercury orbits the Sun at an average distance of about 58 million kilometers, or 36 million miles, much closer than Earth's 149 million kilometers, or 93 million miles. Being so close to the Sun, Mercury experiences a much stronger gravitational pull, which accelerates its orbital speed to an impressive 47 kilometers per second, or 29 miles per second. This high speed allows Mercury to complete a full revolution around the Sun in just 88 Earth days, earning it the title of having the shortest year in the solar system. While a year on Mercury is short, its day, the time it takes for the planet to complete one rotation on its axis, is surprisingly long. Mercury rotates very slowly, taking about 59 Earth days to complete one rotation. This means that a single day on Mercury lasts nearly 2/3 of its year. This slow rotation creates a unique dynamic where, during certain periods, an observer on Mercury would see the sun rise, pause, reverse slightly, and then continue its path across the sky. Mercury's short year and proximity to the sun contribute to its extreme temperature variations. The planet lacks a substantial atmosphere to retain heat, so temperatures on its surface can range from a scorching 430 degrees Celsius, or 800 degrees Fahrenheit, during the day to a freezing -180 degrees Celsius, or -290 degrees Fahrenheit, at night. These extreme conditions make Mercury one of the most inhospitable places in the solar system. Mercury's short year and unique rotation have made it a key focus for scientific exploration. Missions like NASA's Messenger and the ongoing European-Japanese Bepi-Colombo mission have provided valuable insights into Mercury's geology, magnetic field, and atmosphere. Understanding Mercury's orbit and rotational dynamics also helps scientists refine their models of planetary formation and evolution. If you lived on Mercury, you would celebrate a birthday every 88 Earth days, making you considerably older in Mercury years than you are in Earth years. However, with its long days, you'd also experience fewer sunrises and sunsets relative to the number of years that pass. A year on Mercury, lasting only 88 days, is a remarkable consequence of its closeness to the Sun and its rapid orbital speed. This feature, combined with its slow rotation and extreme environment, makes Mercury one of the most intriguing planets in our solar system. Its study continues to deepen our understanding of planetary mechanics and the diverse worlds that exist in our cosmic neighborhood.
The human body contains a surprising amount of iron, enough to create a small nail weighing about 2.5 to 3 grams. While this may seem like a trivial detail, it highlights the crucial role that iron plays in our biology and the intricate way the elements of the Earth are incorporated into living organisms. Iron is an essential element for life, playing a critical role in several physiological processes. The majority of the iron in the human body is found in hemoglobin, the protein in red blood cells responsible for transporting oxygen from the lungs to tissues and organs. Each hemoglobin molecule contains iron atoms that bind to oxygen, enabling efficient oxygen delivery. Iron is also a key component of myoglobin, a protein that supplies oxygen to muscles, and various enzymes that facilitate biochemical reactions essential for metabolism and DNA synthesis. Without sufficient iron, the body cannot produce enough healthy red blood cells, leading to conditions like anemia. The average adult human body contains about 3 to 4 grams of iron. While this might seem like a small amount, it is perfectly balanced to meet the body's needs. If you were to extract all the iron from an average body, it would be enough to forge a nail roughly 2.5 to 3 centimeters long. This striking comparison helps contextualize the presence of iron in our bodies relative to its industrial uses. The iron in our bodies has a cosmic origin. It was formed in the cores of massive stars through nuclear fusion and distributed across the universe during supernova explosions. Over billions of years, this iron became part of the Earth and eventually made its way into the food we eat, integrating into the cycle of life. Humans acquire iron through their diet, consuming it in two forms: heme iron, found in animal-based foods like red meat, poultry and fish, and non-heme iron, found in plant-based foods like beans, lentils, spinach and fortified cereals. The body absorbs heme iron more efficiently, but vitamin C can enhance the absorption of non-heme iron. A balanced diet is crucial to maintaining healthy iron levels. Iron deficiency is one of the most common nutritional disorders worldwide and can lead to symptoms like fatigue, weakness and impaired immune function. Conversely, excessive iron levels, often due to genetic conditions like hemochromatosis, can cause damage to organs such as the liver and heart. This underscores the importance of maintaining appropriate iron levels for overall health. The comparison between the iron in our bodies and a small nail underscores humanity's connection to the natural world and the elements that make up our universe. It also serves as a reminder of how minute quantities of certain elements can have a profound impact on life. The fact that there's enough iron in the human body to make a small nail is a fascinating intersection of biology, chemistry, and astronomy. This simple yet profound fact illustrates how our bodies are intricately designed to utilize the resources of the Earth and the stars for survival. It also highlights the incredible efficiency of nature, where even a small amount of iron can sustain vital processes critical to life.
The idea that a cockroach can live for weeks without its head is one of the most astonishing facts about these resilient insects. This peculiar ability highlights the unique biological systems of cockroaches and their remarkable capacity to survive under extreme conditions. However, while a headless cockroach can survive for a period of time, it ultimately succumbs to dehydration, not the loss of its head. Cockroaches possess several unique physiological traits that allow them to live without their heads. First, their nervous system independence. Unlike humans and other vertebrates, cockroaches have a decentralized nervous system. Their brains are not the sole control center of their bodies. Instead, ganglia, which are clusters of nerve cells located throughout their bodies, control basic functions like movement and reflexes. This means a cockroach can continue to move and respond to stimuli even after its head is removed. Next, minimal blood pressure cockroaches have an open circulatory system, meaning their blood, or hemolymph, is not confined to blood vessels. The absence of high blood pressure means that decapitation doesn't result in significant blood loss, as it would in humans or other animals. Lastly, a simple breathing mechanism. Cockroaches don't rely on their mouths or heads to breathe. Instead, they breathe through small openings called spiracles, located along their bodies. These spiracles allow oxygen to diffuse directly into their tissues, enabling them to survive without a head. Despite their remarkable ability to survive decapitation, cockroaches cannot live indefinitely without their heads. The primary reason they die is dehydration. The head houses the mouthparts and brain centers responsible for drinking and eating. Without a head, the cockroach cannot consume water, and dehydration typically kills it within 1 to 2 weeks. Evolutionary advantages. The ability to survive headless is a testament to the cockroach's evolutionary success. This resilience is part of what has allowed cockroaches to thrive for over 300 million years, surviving mass extinctions and adapting to a wide range of environments. Their durability has earned them a reputation as one of the hardiest creatures on Earth. Scientific and practical implications. The cockroach's ability to survive decapitation has fascinated scientists, prompting studies into their biology and nervous systems. This research has potential implications for understanding decentralized neural systems, which could inform advancements in robotics and artificial intelligence. Myths and misunderstandings. While the resilience of cockroaches is often exaggerated, such as the claim that they could survive a nuclear apocalypse, the fact that they can live without their heads is grounded in biological reality. However, the duration of their survival depends on environmental conditions and their access to water before decapitation. Conclusion. A cockroach's ability to live for weeks without its head is a remarkable demonstration of the resilience and adaptability of nature. This unique trait, driven by their decentralized nervous system, minimal blood pressure and independent breathing mechanism, underscores their status as one of the most durable creatures on Earth. While the thought of a headless cockroach may be unsettling, it serves as a reminder of the diverse and fascinating survival strategies found in the animal kingdom.
The phenomenon of a fungus taking over the bodies and controlling the movements of ants is one of the most extraordinary examples of parasitism in nature. This behavior is primarily associated with fungi from the genus Ophiocordyceps, particularly Ophiocordyceps unilateralis, often referred to as the zombie ant fungus. Found in tropical forests, this fungus exhibits a horrifyingly intricate life cycle that has fascinated scientists and the public alike. The life cycle of the zombie ant fungus. Infection. The fungus begins its life as microscopic spores that attach to the exoskeleton of an ant, usually from the genus Camponotus, commonly known as carpenter ants. The spore penetrates the ant's cuticle and begins to grow inside its body. Control of the host. Once inside, the fungus releases chemicals that affect the ant's central nervous system, effectively hijacking its behavior. The infected ant, now a zombie, exhibits uncharacteristic behaviors, such as leaving its colony and climbing vegetation to an optimal height for fungal growth. Death grip. In a macabre finale, the ant is compelled to bite down on a leaf twig or other substrate in what is known as a death grip. This anchors the ant in place and provides stability for the fungus as it grows and reproduces. After the ant dies, the fungus consumes the ant's tissues and eventually produces a fruiting body that sprouts from the ant's head or other body parts. This fruiting body releases spores into the environment, starting the cycle anew. The exact mechanisms by which the fungus manipulates the ant remain a topic of active research. Scientists believe that the fungus produces a cocktail of chemicals that interfere with the ant's neurological pathways and muscles. Recent studies suggest that the fungus does not directly invade the brain, but instead secretes compounds that control the ant's body, essentially turning it into a puppet. The relationship between Ophiocordyceps fungi and ants is a highly specialized form of parasitism. Each species of Ophiocordyceps often targets specific ant species, demonstrating a long evolutionary history. This specificity ensures that the fungus optimally manipulates its host to enhance its reproductive success. Despite its gruesome nature, the zombie ant fungus plays an important ecological role. By keeping ant populations in check, it helps maintain balance within forest ecosystems. Furthermore, its interactions with ants provide valuable insights into the complex relationships between parasites and hosts. The zombie ant fungus has become a subject of fascination for biologists studying parasitism, behavioral manipulation, and coevolution. Its ability to control behavior raises questions about the biochemical pathways involved, which could have implications for understanding similar mechanisms in other species or even diseases in humans. The idea of a mind-controlling fungus has captured public imagination and has inspired various works of fiction, including the popular video game and television series The Last of Us. These portrayals are often dramatized, but are rooted in the real-life horror of Ophiocordyceps. The zombie ant fungus is a chilling yet fascinating example of nature's ingenuity. Its ability to manipulate behavior, complete its life cycle, and maintain its role in the ecosystem underscores the complexity of parasitic relationships. While it may seem like something out of science fiction, this fungus is a stark reminder of the surprising and often unsettling strategies life on Earth employs to survive and thrive.
Uranus is one of the most unusual planets in our solar system because it rotates on its side. Unlike the other planets, which have axes that are roughly perpendicular to their orbital planes, Uranus has an axial tilt of about 98 degrees. This means that the planet essentially rolls along its orbit, creating unique seasonal and environmental conditions that set it apart from the rest of the solar system. Uranus's extreme axial tilt is unlike anything seen in the solar system. Most planets, including Earth, have a tilt that causes their poles to point slightly away from or toward the Sun as they orbit, creating seasons. However, Uranus's tilt is so extreme that its poles nearly lie in the plane of its orbit. During its 84-year journey around the Sun, each pole gets about 42 years of continuous sunlight, followed by 42 years of darkness. The exact reason for Uranus's unusual tilt remains a mystery, but the most widely accepted theory is that it was caused by a massive collision early in the planet's history. Scientists hypothesize that Uranus was struck by a planet-sized object, possibly as large as Earth or Mars, during the formation of the solar system. This impact likely knocked the planet onto its side, leaving it with its unique orientation. The extreme axial tilt has significant implications for Uranus's environment and seasons. Firstly, because of its sideways orientation, the Sun's position in Uranus's sky changes dramatically over the course of its year. For example, during the summer in one hemisphere, the Sun remains directly overhead at the pole for decades, while the other hemisphere experiences a prolonged winter night. Secondly, Uranus's magnetic field is also tilted relative to its rotational axis, making it significantly misaligned with the planet's center. This creates a lopsided and highly irregular magnetosphere that changes as the planet rotates. Lastly, despite its tilt, Uranus's temperature distribution across the planet is surprisingly uniform, with both poles and the equator being similarly cold. This is likely due to the efficient mixing of heat in its atmosphere. Uranus rotates quickly on its axis, completing one rotation approximately every 17 hours and 14 minutes. Its sideways orientation means that its equator rotates almost perpendicular to its orbital path. This rotation adds to the planet's oddity and contributes to its unique dynamics. The sideways rotation also affects the way Uranus appears from space. Its pale blue-green color, caused by methane in its atmosphere, gives it a serene look, but its rotation causes faint cloud bands and storms to appear in unusual patterns. Unlike planets like Jupiter and Saturn, Uranus's cloud activity is relatively subdued, possibly due to its frigid temperatures. The peculiar tilt of Uranus has made it a fascinating subject for astronomers. Understanding how the tilt affects its weather, magnetic field, and internal structure provides insights into planetary formation and evolution. NASA's Voyager 2 spacecraft, which flew by Uranus in 1986, remains the only mission to have studied the planet up close. But future missions are being considered to explore its unique properties further. Uranus's sideways rotation makes it one of the most intriguing planets in the solar system. Its extreme tilt, likely caused by a massive ancient collision, has shaped its seasons, magnetic field, and overall dynamics in ways that are entirely unique. While much about Uranus remains a mystery, its unusual characteristics continue to captivate scientists and highlight the incredible diversity of planets in our cosmic neighborhood.
The human brain is often described as one of the most complex and extraordinary structures in the known universe. One of its most astonishing features is the vast number of connections between neurons, which far exceeds the estimated number of stars in the Milky Way galaxy. This incredible connectivity is what enables the brain to perform its vast array of functions, from basic survival tasks to abstract thought and creativity. The human brain consists of approximately 86 billion neurons, the specialized cells that transmit information. Each neuron forms connections known as synapses with other neurons, creating an intricate network. On average, a single neuron can connect with thousands of others, resulting in an estimated 100 trillion synaptic connections in the human brain. Some estimates even suggest this number could reach as high as 1 quadrillion in particularly dense areas of the brain. These vast connections are what allow the brain to process and store information. Each synapse serves as a pathway for electrical or chemical signals, enabling communication between neurons. This communication is the foundation of everything the brain does, from regulating basic bodily functions like heartbeat and breathing, to enabling complex activities like language, memory, and problem-solving. The comparison between the brain's synaptic connections and the stars in the Milky Way is more than just a numerical analogy. Both systems are vast and intricate, operating on principles of interconnectedness. However, while the stars in the galaxy are primarily static, the brain's connections are dynamic. Synapses can strengthen, weaken, or even form anew, depending on the brain's activity and experiences. The brain's immense connectivity is what makes it capable of handling the complexity of human thought, emotion, and consciousness. It also underscores the challenges of studying the brain, as mapping and understanding such a vast network is a monumental task. Advanced technologies like functional MRI, optogenetics, and connectomics are helping scientists explore the brain's structure and function, but many mysteries remain. The comparison between the brain's connections and the stars also serves as a source of philosophical and scientific wonder. It highlights the idea that the universe is not only vast externally, but also internally within us. The brain's complexity rivals that of the cosmos, suggesting that understanding ourselves is as profound an endeavor as exploring the stars. The fact that the human brain has more connections than there are stars in the Milky Way is a testament to its unparalleled complexity and efficiency. This intricate network of synapses is the foundation of all human experience and capability, making the brain a true marvel of nature. As science continues to unlock the secrets of this incredible organ, it becomes clear that understanding the brain is key to understanding what it means to be human.
Sound is a mechanical wave that propagates through a medium by vibrating particles. Its speed depends on the properties of the medium, such as its density and elasticity. One fascinating fact about sound is that it travels about 15 times faster through steel than it does through air, illustrating how different materials influence the transmission of sound waves. In air at room temperature, around 20 degrees Celsius or 68 degrees Fahrenheit, sound travels at a speed of approximately 343 meters per second, which is 1,235 kilometers per hour or 767 miles per hour. In contrast, sound travels through steel at an astonishing speed of about 5,960 meters per second, which is 21,456 kilometers per hour or 13,334 miles per hour. This dramatic difference is due to the physical properties of steel compared to air. The speed of sound in a material is determined by two primary factors: elasticity or stiffness and density. Steel is much more elastic than air, meaning it resists deformation and returns to its original shape more efficiently when subjected to stress. This high elasticity allows sound waves to propagate more quickly. While steel is significantly denser than air, its elasticity compensates for this increased density, enabling faster transmission of sound waves. In simpler terms, the tightly packed atoms in steel transmit vibrations more efficiently than the loosely spaced molecules in air. The mathematical relationship governing sound speed, denoted as V in a medium, is given by the formula V equals the square root of E divided by Rho, where E is the material's modulus of elasticity and Rho is its density. Steel's high modulus of elasticity ensures a much higher sound velocity compared to air. The difference in sound speed has practical implications in various fields. Firstly, in engineering and construction, engineers use ultrasonic testing to detect cracks or defects in steel structures. The high speed of sound in steel allows for accurate measurements and diagnostics. Secondly, in seismology, understanding sound propagation in solid materials like steel helps scientists interpret seismic waves during earthquakes, as these waves travel through the Earth's crust and mantle at different speeds depending on the material. Lastly, in communication, submarine communication systems utilize steel cables to transmit signals efficiently over long distances, taking advantage of the faster sound speed in solid materials. While sound travels faster in steel, its perception changes. Steel transmits vibrations so quickly that sounds passing through it may lose fidelity or become distorted compared to those traveling through air. Additionally, the higher speed in steel often makes sounds less audible to the human ear because they don't dissipate in the same way as they do in air. Steel is not the fastest medium for sound transmission. Materials like diamond, which have even greater stiffness, allow sound to travel at speeds exceeding 12,000 meters per second. Conversely, Sound travels slower in less rigid materials like rubber or in highly compressible gases like helium. The fact that sound travels 15 times faster through steel than through air underscores the influence of a medium's physical properties on wave transmission. Steel's combination of high elasticity and density makes it an excellent conductor of sound. This phenomenon has numerous practical applications and serves as a reminder of how the fundamental principles of physics manifest in everyday materials and technologies.
The human stomach is an incredibly resilient organ, designed to handle the harsh environment necessary for digesting food. One of its most fascinating features is its ability to regenerate its lining every 3 to 4 days. This constant renewal is vital for protecting the stomach from the highly acidic gastric juices it produces, which are powerful enough to digest food, and potentially the stomach itself. The stomach lining, or mucosa, is composed of specialized epithelial cells that secrete mucus, enzymes, and hydrochloric acid. The mucus acts as a protective barrier, shielding the stomach tissue from being eroded by the acid and digestive enzymes. However, over time, these cells are damaged or worn down by the harsh environment they maintain. To ensure the stomach continues to function without sustaining lasting damage, the body rapidly replaces these cells through a process of cell division and regeneration. This renewal process is a testament to the body's remarkable ability to maintain balance and repair itself. Without it, the stomach would be prone to developing ulcers or other issues caused by acid damage. Conditions like gastritis and peptic ulcers often occur when this regeneration process is disrupted or overwhelmed, highlighting its critical role in maintaining gastrointestinal health. The constant turnover of the stomach lining is also a reason why some medications, like non-steroidal anti-inflammatory drugs or NSAIDs, can cause stomach irritation. These drugs can interfere with the production of the protective mucus, leaving the lining vulnerable until it regenerates. This underscores the importance of this natural cycle in keeping the stomach functioning optimally. In essence, the stomach's ability to replace its lining every few days is a remarkable example of the human body's adaptability and self-preservation mechanisms, ensuring that it remains capable of digesting food without damaging itself.
The claim that a sneeze can travel up to 100 miles per hour is a fascinating, often cited statement about the human body's reflexive processes. Sneezing or sternutation is a natural mechanism designed to clear irritants such as dust, pollen or mucus from the nasal passages. When triggered, the body launches a rapid and coordinated response involving the respiratory muscles, diaphragm and throat to expel air forcefully through the nose and mouth. The idea that a sneeze can travel at speeds of up to 100 miles per hour, while widely shared, has been debated among scientists. Studies have shown that the velocity of a sneeze is highly variable and depends on factors like the individual's lung capacity, health, and the force of the expulsion. In many cases, the actual speed of a sneeze is likely closer to 30 to 40 miles per hour, though exceptionally strong sneezes might occasionally approach higher speeds. The speed of a sneeze is not its only impressive feature. A sneeze can expel droplets laden with microorganisms and particles over significant distances. These droplets can travel as far as 20 to 25 feet, depending on environmental conditions like airflow and humidity. This characteristic underscores the importance of covering sneezes with a tissue or elbow to minimize the spread of germs, particularly during cold and flu season or pandemics. Overall, while the claim of 100 miles per hour sneezes captures the imagination, it's essential to view it as a rough estimate rather than a universal truth. Regardless of the exact speed, sneezing serves as a powerful and effective defense mechanism to protect the respiratory system.
The idea that humans are bioluminescent, emitting a faint glow, is both surprising and fascinating. Bioluminescence refers to the production and emission of light by living organisms, a phenomenon commonly associated with creatures like fireflies, deep-sea fish, and some jellyfish. In humans, this glow is indeed real, but it is extremely faint and not visible to the naked eye. This phenomenon occurs as a byproduct of biochemical reactions within the body, particularly those involving reactive oxygen species, or ROS. These molecules interact with lipids and proteins, leading to the formation of excited molecules that release photons of light as they return to their ground state. This light emission is part of the natural metabolic processes that occur within our cells. Research has confirmed this subtle glow using highly sensitive imaging equipment. For instance, a 2009 study conducted by Japanese researchers utilized ultra-sensitive cameras to detect and map the human body's bioluminescent emissions. They discovered that the intensity of this glow fluctuates throughout the day, peaking in the late afternoon and diminishing at night. It is most pronounced around the face, neck, and upper chest, likely due to higher metabolic activity in these regions. While human bioluminescence has no known functional purpose, it highlights the intricate and often overlooked processes occurring within our bodies. It also underscores our connection to other bioluminescent organisms, showing that this phenomenon is not exclusive to the animal or plant kingdoms. This faint, invisible glow is a testament to the remarkable complexity of life and the energy transformations that sustain it.
The claim that the human brain uses about the same amount of power as a 10-watt light bulb is a striking way to illustrate the brain's efficiency and energy demands. The comparison is rooted in the fact that the brain, despite accounting for only about 2% of an average adult's body weight, consumes approximately 20% of the body's total energy. This energy usage translates to about 10 watts of power in electrical terms, a level comparable to the energy needed to illuminate a small, energy-efficient light bulb. The brain's energy consumption is primarily devoted to maintaining its complex functions. Neurons, the brain's primary cells, communicate through electrical and chemical signals, a process that requires significant energy. Most of this energy is used to fuel ion pumps that maintain the electrical charge of neurons, allowing them to transmit signals effectively. The remaining energy supports processes like producing neurotransmitters, managing waste products, and maintaining cellular health. This efficiency is remarkable given the brain's capabilities. It processes vast amounts of information, enables complex thought, governs bodily functions, and manages sensory input, all while running on the energy equivalent of a small household light bulb. To sustain this activity, the brain relies on a continuous supply of oxygen and glucose delivered through the bloodstream. Even slight disruptions in this supply can impair cognitive and physical functions. The comparison to a 10-watt bulb also serves as a metaphor for the brain's sophistication and adaptability. While a light bulb simply emits light, the brain orchestrates intricate processes that define human experience. This highlights the elegance of biological systems and their ability to achieve high performance with minimal energy. The fact that such a small amount of power drives the seat of human consciousness and creativity underscores the brain's extraordinary design and functionality.
The phenomenon of being taller in the morning than at night is a fascinating example of how our bodies interact with gravity throughout the day. This height difference, which can range from a few millimeters to as much as a centimeter, occurs due to the compression and decompression of the intervertebral discs in the spine. The spine consists of vertebrae separated by intervertebral discs, which are gel-like cushions that act as shock absorbers and provide flexibility to the spine. These discs are composed primarily of water, making them highly elastic. During the day, as we stand, sit, and engage in various activities, the weight of the body and the force of gravity compress these discs. This compression forces some of the fluid out of the discs, reducing their thickness and in turn slightly shortening our overall height. When we lie down to sleep at night, the pressure on the spine is significantly reduced. In this horizontal position, the discs have the opportunity to rehydrate and regain their original thickness as fluid is reabsorbed. By morning, this process restores the lost height, leaving us slightly taller when we wake up. This daily fluctuation in height is entirely normal and does not indicate any health issues. However, it can vary depending on factors such as age, hydration levels, and physical activity. For instance, younger individuals may experience a more noticeable height difference because their discs are more hydrated and elastic compared to those of older adults, whose discs may lose some of their water content and elasticity over time. This phenomenon serves as a reminder of the dynamic nature of the human body and its constant interaction with environmental forces. It also underscores the importance of maintaining spinal health through good posture, regular exercise, and staying hydrated to support the spine's natural ability to function and recover.
The statement that every human starts as a single cell for about 30 minutes after conception highlights the remarkable beginnings of human life. This single cell, called the zygote, forms when a sperm cell from the father successfully fertilizes an egg cell from the mother during conception. The zygote represents the very first stage of human development and contains the complete set of DNA necessary to create a unique individual, with half the genetic material contributed by each parent. For approximately 30 minutes after fertilization, the zygote exists as a single undivided cell. During this brief but crucial phase, the zygote undergoes several biological processes to prepare for its first division. The DNA from the sperm and egg combine, creating a single nucleus containing a full set of chromosomes. This merging of genetic material establishes the blueprint for the individual's physical and biological traits, from eye color to susceptibility to certain conditions. After this initial period, the zygote begins the process of mitotic division, where it splits into 2 cells, then 4, and so on. This marks the beginning of rapid cellular proliferation, eventually leading to the formation of a blastocyst, which implants into the uterine wall to continue development. Over time, these cells differentiate into specialized cell types, forming tissues, organs, and ultimately the fully developed human body. The fact that human life begins as a single cell underscores the incredible complexity of biological development. This single cell contains all the instructions necessary to create a fully functioning organism, a testament to the precision and efficiency of genetic programming. Understanding this early stage of life not only provides insights into human biology, but also informs research into developmental disorders, fertility treatments, and regenerative medicine.
The claim that your skin replaces itself entirely about every 27 days highlights the skin's remarkable regenerative abilities. The skin is the body's largest organ, serving as a protective barrier against environmental threats such as pathogens, UV radiation, and physical damage. To maintain its integrity and functionality, the skin undergoes a continuous process of renewal, shedding old cells and generating new ones. This process begins in the innermost layer of the epidermis, the basal layer, where keratinocytes, the primary cell type in the skin, are produced. These cells gradually move upward through the layers of the epidermis, undergoing changes as they travel. By the time they reach the skin's surface, they have become flattened, dead cells filled with keratin, a protein that helps form the skin's protective outer layer. These dead cells are eventually sloughed off in a process known as desquamation. The entire cycle of skin renewal, from the production of new keratinocytes to the shedding of dead skin cells, takes approximately 27 to 30 days in most individuals. However, the rate of this process can vary depending on factors such as age, genetics, health, and lifestyle. For instance, younger people tend to have faster skin cell turnover rates, while the process slows down with age, contributing to the appearance of wrinkles and less vibrant skin. This natural renewal process is crucial for maintaining skin health. It helps repair damage, remove dead cells, and keep the skin supple and resilient. Proper skincare can support this cycle by promoting hydration, exfoliation, and protection against harmful elements. For example, regular exfoliation helps remove excess dead skin cells, while moisturizing and using sunscreen protect the skin and enhance its ability to regenerate effectively. Overall, the skin's ability to replace itself entirely every month is a testament to its dynamic and adaptive nature. This constant renewal not only preserves the skin's protective role, but also reflects the body's broader capacity for self-repair and maintenance.
The cornea of the eye is indeed unique in that it is the only part of the human body that does not receive blood. This characteristic is crucial to its function and illustrates how the body adapts to meet specific needs. The cornea is the transparent, dome-shaped outer layer of the eye that covers the iris, pupil, and anterior chamber. Its primary role is to refract or bend light to help focus it onto the retina, enabling clear vision. To fulfill this function, the cornea must remain completely transparent, which is why it lacks blood vessels. Blood vessels in the cornea would interfere with its transparency and obstruct light from passing through. Instead of relying on blood for nourishment, the cornea receives oxygen and nutrients through other means. Oxygen is primarily absorbed directly from the air and diffused through the tear film that coats the cornea's surface. Nutrients are supplied by the aqueous humor, a clear fluid located in the chamber just behind the cornea. The absence of blood vessels also plays a role in reducing the likelihood of immune reactions. Since the cornea does not contain blood vessels, it is considered an immune-privileged site, meaning it is less prone to immune system attacks. This is one reason why corneal transplants have a high success rate compared to other types of organ transplants. Despite its avascular nature, the cornea is richly innervated by nerves, particularly from the ophthalmic branch of the trigeminal nerve. This makes the cornea highly sensitive to pain, pressure and temperature, serving as a protective mechanism to prevent injury and maintain its integrity. Overall, the cornea's lack of blood supply is a remarkable adaptation that ensures it can perform its critical role in vision. Its reliance on alternative sources for oxygen and nutrients underscores the complexity and efficiency of the body's design. This feature, combined with its immune privilege and high sensitivity, highlights the cornea's specialized structure and function.
The statement that earwax is technically a type of sweat is a surprising but accurate fact rooted in the biology of the glands responsible for its production. Earwax, or cerumen, is a natural substance produced in the ear canal to protect and clean the ears. It helps trap dust, debris and microorganisms, preventing them from reaching the delicate structures of the inner ear. Additionally, earwax has antibacterial and antifungal properties, further safeguarding the ear. The connection between earwax and sweat lies in its origin. Cerumen is produced by ceruminous glands, which are specialized sweat glands located in the ear canal. These glands are modified apocrine glands, a type of sweat gland found in areas such as the armpits and groin. Apocrine glands differ from the more common eccrine sweat glands, which are distributed across most of the body and primarily produce watery sweat for temperature regulation. Apocrine glands, on the other hand, secrete a thicker, lipid-rich substance. In the ear canal, ceruminous glands work alongside sebaceous glands, which produce oils. The secretions from these glands combine to form earwax. The composition of earwax varies among individuals and populations, influenced by genetics, diet, and environmental factors. For instance, earwax can be classified as either wet or dry, with the wet type being more common in individuals of African or European descent, and the dry type more prevalent among East Asians and Native Americans. While earwax is a natural and necessary substance, excessive buildup can lead to discomfort, hearing problems, or even infections. However, the ear is typically self-cleaning, as movements of the jaw during activities like chewing and talking help push earwax outward. In most cases, minimal intervention is needed to maintain ear health. Understanding that earwax is a type of sweat highlights the diversity of sweat gland functions beyond temperature regulation. This unique adaptation demonstrates how the body repurposes similar biological structures to meet specialized needs in different areas. Far from being an inconvenience, earwax plays a crucial role in maintaining ear health and protecting one of our most important senses, hearing.
The human body contains trace amounts of gold, approximately 0.2 milligrams on average, and most of this gold is found in the blood. While this quantity is minuscule, equivalent to about 1/10 the weight of a grain of sand, it highlights the fascinating ways in which elements integral to the Earth's composition are also present in our bodies. Gold in the human body is not present as solid particles or visible specks, but exists in ionic form, dissolved in the bloodstream and distributed throughout tissues. It is thought to play a minor role in some biochemical processes, although its exact biological functions are not well understood. Gold is chemically inert, meaning it does not readily participate in chemical reactions, which makes it safe to exist in trace amounts in the body without causing harm. The presence of gold and other trace elements in the human body is a reflection of our shared evolutionary history with the Earth. These elements, including gold, are found naturally in the environment and enter the body through the food we eat, the water we drink, and the air we breathe. For instance, gold can be absorbed from certain plant-based foods, as plants draw trace amounts of it from the soil. While the amount of gold in the human body is too small to have commercial value, its presence is often used metaphorically to emphasize the preciousness of human life. Interestingly, the inert and non-toxic properties of gold have also made it valuable in medical applications, such as in certain treatments for arthritis and in diagnostic tools. Overall, the presence of gold in the human body underscores the interconnectedness between biology and the Earth's elemental makeup. It serves as a reminder of how even the tiniest amounts of the universe's building blocks are woven into the fabric of life, contributing to the awe-inspiring complexity of the human body.
Saturn, the second largest planet in our solar system, is famous for its stunning ring system, but it has another fascinating characteristic: it could theoretically float in water. This unusual fact stems from the planet's composition and density. Saturn is classified as a gas giant, meaning it is primarily made of gases like hydrogen and helium, with only a small, dense core of heavier elements. Because of this composition, its average density is incredibly low, even lower than water. The average density of Saturn is about 0.687 grams per cubic centimetre, which is significantly less than the density of water, at 1 gram per cubic centimetre. This means that if there were an ocean large enough to hold Saturn, the planet would indeed float, much like an ice cube in a glass of water. However, this is of course a purely hypothetical scenario, since such a vast body of water doesn't exist in the universe as we know it. Saturn's low density highlights the unique nature of gas giants compared to terrestrial planets like Earth. While Earth and other rocky planets have solid surfaces and higher densities due to their composition of metals and silicates, gas giants are primarily composed of lighter elements, which makes them much less dense. Saturn, in particular, has the lowest density of all the planets in the solar system, which is why it holds this peculiar distinction. This characteristic is also a reminder of how different the environments and physical properties of planets can be. The gases that make up Saturn are held together by gravity, and the planet has no solid surface. The density of its atmosphere decreases as you move outward, blending seamlessly into the vacuum of space. This means that if you were to descend into Saturn's atmosphere, you would encounter increasingly dense layers of gas, but you would never find a solid surface to land on. Saturn's ability to float in water is a fun fact that underscores the diversity and wonder of the planets in our solar system. It also helps us understand the physical and chemical properties that define gas giants, offering insight into the formation and structure of these massive planets.
The Moon, Earth's only natural satellite, experiences extreme temperature variations due to the lack of an atmosphere to regulate and distribute heat. On the side facing away from the Sun, commonly referred to as the dark side during nighttime, the surface temperature can plummet to an astonishing -280 degrees Fahrenheit, which is -173 degrees Celsius. This drastic drop occurs because the Moon cannot retain heat once the Sun sets, as it lacks an insulating atmosphere like Earth's. The Moon's temperature extremes are a direct result of its lack of atmosphere. On Earth, our atmosphere acts as a blanket, trapping heat during the day and redistributing it to maintain relatively stable temperatures. The Moon, however, has no such atmospheric layer. Instead, its surface is exposed to the vacuum of space, allowing it to rapidly lose heat through thermal radiation when the Sun is not shining on it. A lunar day lasts about 29.5 Earth days, meaning that one side of the Moon is exposed to sunlight for approximately 2 weeks, followed by 2 weeks of darkness. During the daytime, the surface temperature can soar to around 260 degrees Fahrenheit, or 127 degrees Celsius. But once the Sun sets, the heat quickly dissipates, and the temperature plunges to -280 degrees. These extreme conditions make the Moon one of the harshest environments in the solar system. The Moon's regolith, or surface layer, also plays a role in these temperature fluctuations. Made of fine dust and rocky debris, the regolith has low thermal conductivity, meaning it doesn't store heat well. As a result, the surface cools rapidly once the Sun disappears, while the deeper layers of the regolith remain relatively unaffected by these temperature swings. These extreme temperatures pose significant challenges for lunar exploration and habitation. Spacecraft, instruments, and habitats must be designed to withstand both the searing heat of the lunar day and the frigid cold of the lunar night. For example, the Apollo missions, which sent astronauts to the Moon between 1969 and 1972, required advanced thermal control systems to protect equipment and astronauts from these extreme conditions. The stark temperature difference on the Moon provides insight into how atmospheres play a crucial role in moderating planetary climates. It also highlights the unique challenges of exploring and potentially colonizing worlds without atmospheres. Understanding and adapting to these extremes is vital as humanity sets its sights on returning to the Moon and establishing a long-term presence there through programs like NASA's Artemis mission.
Saturn's North Pole is home to one of the most fascinating and mysterious weather phenomena in the solar system, a giant, hexagon-shaped storm. First discovered by the Voyager spacecraft during their flybys in the early 1980s and later studied in greater detail by NASA's Cassini spacecraft, this massive storm has captivated scientists for decades due to its unusual geometric shape and immense scale. The hexagon is an enormous jet stream encircling Saturn's North Pole, spanning about 20,000 miles or 32,000 kilometers in diameter, large enough to fit 4 Earths across it. Unlike most storms, which tend to be circular or amorphous in shape, this storm's 6-sided symmetry is remarkably precise, making it a unique feature in planetary weather systems. The hexagon rotates counterclockwise, with winds reaching speeds of up to 200 miles per hour or 320 kilometers per hour. Within the hexagon, there is another intriguing feature: a massive, hurricane-like vortex at the very center of Saturn's North Pole. This vortex has a clearly defined eye and towering clouds, resembling hurricanes on Earth, but much larger and more intense. The exact cause of the hexagonal shape is still a subject of scientific investigation, but researchers believe it is related to the dynamics of Saturn's atmosphere. One leading theory suggests that the hexagon is a standing wave pattern created by differences in wind speeds at various latitudes. Laboratory experiments have shown that when fluids are rotated at different speeds, polygonal shapes can form, lending support to this hypothesis. Another factor may be the absence of solid landforms or a substantial atmosphere to disrupt the flow of winds on Saturn, allowing the hexagonal pattern to remain stable over time. Unlike Earth's weather systems, which are influenced by oceans, continents, and atmospheric moisture, Saturn's atmosphere is composed mostly of hydrogen and helium, with minimal friction to disturb these large-scale patterns. What makes the hexagon even more remarkable is its apparent longevity. The storm has been observed consistently for more than 40 years, suggesting that it may have been present for centuries or even millennia. This stability is unusual for a storm system, as most storms on Earth dissipate relatively quickly. The hexagon's durability highlights the unique conditions of Saturn's atmosphere, where powerful jet streams can persist for extended periods. Saturn takes about 29.5 Earth years to complete one orbit around the Sun, meaning each season on the planet lasts roughly 7 years. The hexagon becomes more visible during Saturn's spring and summer in the northern hemisphere, as sunlight illuminates the pole, allowing spacecraft and telescopes to observe it in greater detail. During the winter, when the pole is shrouded in darkness, observations become more challenging. The hexagonal storm provides a unique opportunity to study atmospheric dynamics on a gas giant. By understanding how such a phenomenon forms and persists, scientists can gain insights into the behavior of planetary atmospheres both within and beyond our solar system. It also raises questions about whether similar patterns might exist on other gas giants like Jupiter or exoplanets with similar atmospheric compositions. In summary, Saturn's hexagonal storm is not only a visual marvel, but also a scientific enigma. Its geometric perfection, massive scale, and persistence make it one of the most intriguing features in the solar system, offering a glimpse into the complex and alien weather systems of a distant world. The Sun, the massive star at the center of our solar system, is constantly losing mass at an astonishing rate of 4 million tons per second. This phenomenon occurs because the Sun is continuously converting its mass into energy through the process of nuclear fusion. This energy powers the Sun's light and heat, which sustain life on Earth and govern the dynamics of the entire solar system. How the Sun loses mass. At the core of the Sun, temperatures reach an incredible 15 million degrees Celsius, or 27 million degrees Fahrenheit, and pressures are unimaginably high. Under these conditions, hydrogen nuclei, or protons, collide and fuse together to form helium. This process, known as nuclear fusion, releases a tremendous amount of energy according to Einstein's famous equation, E equals mc squared. Here, m represents the mass lost during fusion and c, the speed of light, amplifies even a small amount of mass into an enormous amount of energy. Each second, approximately 600 million tons of hydrogen are fused into helium in the Sun's core. While most of the mass remains in the form of helium, about 4 million tons are converted into energy which radiates outward as sunlight and other forms of electromagnetic radiation. Solar wind contribution. In addition to mass lost through nuclear fusion, the Sun loses matter via the solar wind, a stream of charged particles, mostly electrons, protons and helium nuclei, that are ejected from the Sun's outer atmosphere, or corona. This stream spreads throughout the solar system, influencing planetary atmospheres and creating phenomena like the auroras on Earth. Although the solar wind accounts for a much smaller mass loss compared to nuclear fusion, it still contributes to the gradual erosion of the Sun's total mass, the scale of mass loss. While 4 million tons per second sounds enormous, it's a tiny fraction of the Sun's total mass, which is about 2 times 10 to the 30th kilograms, 2 followed by 30 zeros. Over the Sun's 4.6 billion year lifetime, it has lost only about 0.03% of its total mass. This means that the Sun's mass loss has a negligible impact on its gravitational pull and its ability to sustain the solar system. Despite the Sun's immense energy output and mass loss, it is remarkably stable and will continue shining for billions of years. It is currently in the middle of its life cycle, known as the main sequence, where it steadily converts hydrogen into helium. However, as the Sun ages, it will eventually exhaust its hydrogen supply, leading to changes in its structure and size. In about 5 billion years, the Sun will enter the red giant phase, expanding to engulf the inner planets, including Earth. During this phase, the Sun will lose mass more rapidly as it sheds its outer layers into space, forming a planetary nebula. Eventually, it will collapse into a white dwarf, a dense remnant that will no longer undergo nuclear fusion. The Sun's mass loss has subtle but measurable effects on the solar system. As the Sun loses mass, its gravitational pull weakens slightly, causing the orbits of planets to slowly drift outward. Over billions of years, this will slightly alter the distances between the Sun and its planets, though the effect is minimal on human timescales. The Sun's constant mass loss is a reminder of the dynamic and ever-changing nature of the universe. It underscores the immense energy production that sustains life on Earth while hinting at the inevitable changes that all stars undergo. This process also highlights the profound relationship between mass and energy, a cornerstone of modern physics. In summary, the Sun's loss of 4 million tons of mass every second is a natural and ongoing process driven by nuclear fusion and solar wind. While it has little immediate effect on the solar system, it plays a crucial role in powering the Sun and shaping its life cycle over billions of years.
Rogue planets, also known as free-floating planets or nomadic planets, are celestial bodies that wander through space without being gravitationally bound to a star. Unlike planets in solar systems which orbit a central star, rogue planets travel through the galaxy untethered. These enigmatic objects are fascinating to scientists because they challenge traditional definitions of planets and expand our understanding of planetary formation and behavior. What are rogue planets? A rogue planet is essentially a planet that does not orbit a star. Instead, it drifts freely through interstellar space. These planets are thought to be similar in composition to regular planets, ranging in size from small rocky Earth-like worlds to massive gas giants. However, because they lack a nearby star to illuminate them, rogue planets are extremely difficult to detect and study. How do rogue planets form? Scientists believe rogue planets can form in two main ways. First, ejection from a star system. During the early stages of a solar system's formation, gravitational interactions between planets and other massive objects, like stars or gas clouds, can lead to one or more planets being flung out of the system. This violent process, known as planetary ejection, results in planets that roam the galaxy alone. Second, direct formation in isolation. Some rogue planets may form directly in interstellar space, much like stars do. In this scenario, a cloud of gas and dust collapses under its own gravity, but it doesn't gather enough mass to ignite nuclear fusion, which is the process that turns stars into luminous bodies. Detection and challenges. Rogue planets are incredibly difficult to observe because they do not emit light like stars and do not reflect light from a nearby star. Instead, they are often detected using indirect methods. Microlensing. When a rogue planet passes in front of a distant star, its gravity bends and magnifies the star's light in an effect called gravitational microlensing. This allows astronomers to infer the presence of the planet. Infrared observation. Rogue planets may emit faint infrared radiation due to residual heat left over from their formation, which can be picked up by specialized telescopes. In 2021, astronomers discovered a rogue planet candidate in the Milky Way using microlensing techniques. Some estimates suggest there may be billions of rogue planets in our galaxy alone, potentially outnumbering stars. Life on rogue planets? Although rogue planets are cold and dark due to the absence of a nearby star, some scientists speculate that certain types of rogue planets might still harbor life. For instance, a rogue planet with a thick atmosphere and internal heat generated by radioactive decay or tidal forces could sustain liquid water beneath its surface. Similarly, subsurface oceans, like those thought to exist on moons such as Europa and Enceladus in our solar system, could provide environments where life might thrive even in the absence of sunlight. The scientific significance of rogue planets. Studying rogue planets is crucial for understanding planetary formation and the dynamic processes that shape solar systems. These wandering worlds provide clues about the chaotic nature of early solar systems and the mechanisms that lead to planetary ejection. They also offer a unique perspective on the diversity of planets in the universe, as their isolation challenges traditional assumptions about planetary environments. Moreover, rogue planets might act as stepping stones for future space exploration. Their abundance and potential proximity to Earth mean that in the distant future, they could serve as waypoints for interstellar travel or exploration. A mysterious class of objects, rogue planets blur the lines between planets, brown dwarfs, objects too large to be planets but too small to sustain nuclear fusion like stars, and other celestial bodies. Some scientists argue that rogue planets with star-like characteristics should be classified differently, adding complexity to the debate over how we define planets. In summary, rogue planets are mysterious and awe-inspiring objects that challenge our understanding of planetary science. Their existence reveals the dynamic and often chaotic nature of the universe, offering a glimpse into worlds unbound by the gravitational pull of a star. As detection methods improve, we may uncover more of these wandering worlds and learn even more about their origins, characteristics, and potential for hosting life.
Jupiter, the largest planet in our solar system, is not only known for its immense size and iconic Great Red Spot, but also for its extraordinary number of moons. As of 2024, astronomers have confirmed that Jupiter has 92 moons, making it the planet with the most natural satellites in the solar system, surpassing even Saturn, which has 83 confirmed moons. These moons range in size, composition, and characteristics, providing a fascinating glimpse into the diversity of celestial objects orbiting a giant planet. Jupiter's four largest and most well-known moons, Io, Europa, Ganymede, and Callisto, are called the Galilean moons, named after the astronomer Galileo Galilei, who discovered them in 1610. These moons are some of the most studied objects in the solar system due to their unique features. Io, the most volcanically active body in the solar system, has a surface constantly reshaped by massive eruptions caused by tidal forces from Jupiter's gravity. Europa, beneath its icy crust, is believed to harbour a vast subsurface ocean, making it a prime candidate in the search for extraterrestrial life. Ganymede, the largest moon in the solar system, is even bigger than the planet Mercury and is the only moon known to have its own magnetic field. Callisto, a heavily cratered ancient moon, has a surface that is one of the oldest in the solar system, preserving a record of impacts over billions of years. Beyond the Galilean moons, Jupiter has dozens of smaller satellites that vary greatly in size and composition. These moons are generally divided into two categories: regular moons and irregular moons. Regular moons have nearly circular orbits and lie close to Jupiter's equatorial plane. They likely formed from the same disk of gas and dust that created Jupiter. Examples include Amalthea, Thebe, Adrastea, and Metis, which are relatively small compared to the Galilean moons. Irregular moons are captured objects, likely asteroids or comets, that were gravitationally snagged by Jupiter. They have highly elliptical, inclined, and sometimes retrograde orbits, meaning they orbit in the opposite direction of Jupiter's rotation. Most of Jupiter's moons fall into this category, with clusters named after their orbital characteristics, such as the Himalaya group or Ananke group. The tally of Jupiter's moons has steadily increased over the years thanks to advancements in telescope technology and observation techniques. Many of the newly discovered moons are tiny, with diameters of just 1 to 3 kilometers, making them difficult to detect. These discoveries often involve large-scale surveys using ground-based telescopes equipped with sensitive cameras, such as those conducted in Hawaii or Chile. In early 2023, astronomers announced the discovery of 12 additional moons, bringing Jupiter's total to 92. These discoveries highlight the dynamic nature of planetary science as new moons are continuously being identified and confirmed. Jupiter's massive size and strong gravitational pull make it a natural collector of moons. Its gravity allows it to capture objects that stray too close, such as asteroids and comets. Additionally, during its formation, Jupiter had a massive disk of gas and dust surrounding it, from which some of its moons coalesced. This combination of capture and co-formation processes has led to Jupiter's impressive collection of moons. Studying Jupiter's moons provides valuable insights into the formation and evolution of the solar system. The Galilean moons, in particular, are like mini-worlds with diverse geological and atmospheric processes. Europa, with its potential subsurface ocean, is of great interest in the search for extraterrestrial life, while Io offers a window into extreme volcanic activity. Additionally, the irregular moons offer clues about Jupiter's gravitational influence and the population of objects in the outer solar system. These moons may include ancient remnants of the early solar system, preserved in their current orbits for billions of years. Several missions are focused on studying Jupiter and its moons. NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, has provided detailed data about the planet and its environment, including close flybys of some of its moons. The upcoming Europa Clipper mission, set to launch in the 2020s, will specifically investigate Europa's habitability. Additionally, the European Space Agency's JUICE, or Jupiter Icy Moons Explorer mission, launching in 2023, aims to study Ganymede, Callisto, and Europa in detail. Jupiter's 92 moons showcase the planet's gravitational dominance and its role as a miniature solar system within our larger solar system. From the volcanic hellscape of Io to the icy oceans of Europa, these moons offer a wealth of scientific opportunities. As technology improves and future missions explore these fascinating worlds, Jupiter's moons will continue to provide key insights into the mysteries of the cosmos.
Mars, the fourth planet from the Sun, is a fascinating world with many peculiarities, and one of its most mesmerizing features is its blue sunsets. Unlike Earth, where sunsets appear warm hues of orange, pink and red, Martian sunsets take on an ethereal blue tint, providing a striking visual contrast to the planet's dusty, red-hued landscape. The unique coloration of Martian sunsets is caused by the interaction between sunlight and the fine dust particles that dominate Mars's thin atmosphere. On Earth, sunsets appear red or orange due to a phenomenon called Rayleigh scattering, where shorter wavelengths of light, blue and violet, are scattered by atmospheric molecules, leaving the longer wavelengths, red and orange, to dominate. Mars, however, experiences a different type of scattering known as Mie scattering, caused by the fine, iron-rich dust particles suspended in its atmosphere. These particles are just the right size to scatter blue light more efficiently than other colors. During sunset, when sunlight passes through a longer column of the Martian atmosphere, the blue light is scattered forward, concentrating it in the direction of the Sun. This effect makes the Sun and the area around it appear bluish, creating the iconic Martian blue sunset. Mars's atmosphere is incredibly thin, about 1% the density of Earth's, and is composed mostly of carbon dioxide, 95%. Despite its thinness, it is filled with fine dust particles, many of which are lifted into the atmosphere by frequent dust storms. This omnipresent dust plays a crucial role in shaping the colour and appearance of the Martian sky. Interestingly, during the day the Martian sky appears a pale butterscotch or yellowish red, largely due to sunlight scattering off the iron oxide-rich dust that gives Mars its nickname, the Red Planet. However, during sunset the concentration of scattered blue light becomes pronounced, creating the stunning contrast. Mars's blue sunsets were first captured by robotic missions exploring the planet, such as NASA's Spirit, Opportunity, Curiosity and Perseverance rovers. These rovers provided photographic evidence of the phenomenon, which matches scientists' predictions about the scattering effects in the Martian atmosphere. For example, NASA's Curiosity rover, which has been exploring Mars since 2012, captured some of the most detailed images of these blue sunsets from Gale Crater. The images show how the Sun dips below the horizon, surrounded by a glowing bluish halo. The Martian blue sunset highlights the intricate interplay between light and the environment. On Earth, our atmosphere scatters blue light across the sky, giving it its characteristic color during the day. On Mars, the situation is reversed. Blue is more prominent at sunset due to the specific size, composition and behavior of dust particles in the thin atmosphere. This difference also underscores how unique each planetary environment is. The optical phenomena we take for granted on Earth, like sunsets, can look dramatically different elsewhere in the solar system, influenced by factors such as atmospheric composition, pressure and particle size. The blue sunsets of Mars have become a symbol of the alien beauty of the Red Planet and a source of inspiration for scientists and dreamers alike. They remind us that even in environments vastly different from our own, there are moments of profound beauty. These sunsets offer a glimpse of what it might be like for future astronauts to stand on the Martian surface, witnessing a sky that is at once familiar and utterly alien. Conclusion. Mars's blue sunsets are a striking example of how the interplay of light and atmospheric conditions can produce phenomena that are both scientifically fascinating and visually stunning. They serve as a reminder of the unique characteristics of other worlds and the importance of exploring and understanding the vast diversity of the universe. From the pale blue dot of Earth to the blue-tinted sunsets on Mars, our solar system is full of wonders waiting to be uncovered.
The phenomenon of a star being stretched into spaghetti if it passes too close to a black hole is a dramatic and scientifically fascinating process known as spaghettification or tidal disruption. This effect highlights the immense gravitational forces that black holes exert on their surroundings and provides a glimpse into the extreme environments near these cosmic giants. What is spaghettification? Spaghettification refers to the extreme stretching and elongation of an object, such as a star, caused by the intense tidal forces near a black hole. Black holes have incredibly strong gravitational fields due to their massive density. As an object approaches the black hole, the gravitational pull it experiences varies significantly across its length. The side of the object closer to the black hole feels a much stronger gravitational force than the far side, creating a tidal effect. If a star ventures too close to the black hole's event horizon, the boundary beyond which nothing can escape, these tidal forces become so intense that the star is stretched into a thin, elongated shape resembling spaghetti. This process can tear the star apart entirely, breaking it into streams of stellar material. The intensity of tidal forces depends on the mass of the black hole and the distance of the star from it. Smaller black holes with masses comparable to a few times that of the Sun have stronger tidal forces near their event horizons, making spaghettification likely even before an object crosses the event horizon. Larger black holes, such as supermassive black holes found at the centers of galaxies, have weaker tidal forces near their event horizons, allowing objects to approach closer before experiencing spaghettification. When the star gets too close to the black hole, the side facing the black hole is pulled more strongly, stretching the star along the direction of gravity. The star is simultaneously compressed along its width due to gravitational forces acting perpendicularly, resulting in a long, thin stream of material. Eventually, the star's material is torn apart and forms an elongated stream of gas. The destruction of a star by a black hole, known as a tidal disruption event, or TDE, is a rare but spectacular cosmic event. As the star's material spirals into the black hole, it forms an accretion disk, a swirling disk of superheated gas and dust. The process generates immense energy, producing bright flares of electromagnetic radiation, including X-rays, ultraviolet, and visible light. These flares are detectable by astronomers and provide valuable information about black holes and the extreme physics governing them. In 2020, astronomers observed a notable TDE named at 2019 Keys, which occurred about 215 million light-years away in the constellation Eridanus. This event gave scientists one of the clearest views of a star being torn apart by a black hole. The likelihood and nature of spaghettification depend on the mass of the black hole. Stellar mass black holes. These smaller black holes, formed from the collapse of massive stars, have more intense tidal forces near their event horizons. A star encountering such a black hole would be shredded and stretched far before it even reaches the event horizon. Supermassive black holes. These giants, with masses millions to billions of times that of the Sun, have weaker tidal forces near their event horizons. A star can approach much closer before being torn apart. In some cases, the star may partially survive the encounter, with only some of its material being accreted. Spaghettification and TDEs offer astronomers a rare opportunity to study black holes indirectly. Since black holes themselves emit no light, observing the bright flares caused by TDEs allows scientists to learn about the mass and spin of black holes, the behavior of matter under extreme gravitational forces, and the processes governing accretion disks and energy generation near black holes. These events also help confirm predictions made by Einstein's general theory of relativity, particularly regarding the effects of extreme gravity on matter and light. The spaghettification of a star serves as a striking reminder of the immense power of black holes, the most extreme objects in the universe. It showcases how gravity, one of the fundamental forces of nature, can dominate and shape the behavior of matter on an astronomical scale. For a star, an encounter with a black hole marks its ultimate demise, but for astronomers, it illuminates some of the deepest mysteries of the cosmos. Spaghettification is a dramatic and fascinating phenomenon that exemplifies the incredible forces at play near black holes. While terrifying in its implications, it provides invaluable insights into the workings of the universe and the extreme conditions that define black hole environments. Each tidal disruption event observed offers a rare chance to study these enigmatic cosmic monsters, advancing our understanding of space, time, and gravity.
Alpha Centauri, the closest star system to Earth, is a fascinating and complex celestial neighbor. Situated just over 4.37 light-years away from our solar system, it is a three-star system consisting of Alpha Centauri A, Alpha Centauri B, and Proxima Centauri. Despite its proximity in cosmic terms, the distance underscores the vast scale of interstellar space, as light traveling at 186,000 miles per second takes over 4 years to reach us from this system. The Alpha Centauri system consists of 3 distinct stars, Alpha Centauri A and B. These 2 stars form a binary pair orbiting each other in a shared gravitational dance. Alpha Centauri A is a G-type star similar to our Sun, slightly larger and brighter. Alpha Centauri B is a K-type star, slightly smaller and cooler than the Sun. They orbit each other at an average distance of about 11 astronomical units, roughly the same distance as Saturn is from the Sun. Proxima Centauri, this is the smallest and faintest of the 3 stars. It is a red dwarf star located about 0.22 light-years from Alpha Centauri A and B. Proxima Centauri is the closest individual star to Earth at a distance of 4.24 light-years. Proxima Centauri is particularly intriguing because it has at least 2 known planets, Proxima b, a rocky exoplanet located in the star's habitable zone, where temperatures might allow for liquid water to exist on its surface. Proxima b is only slightly larger than Earth and has sparked considerable interest as a potential location for extraterrestrial life. Proxima c, a larger, possibly gaseous planet with a much wider orbit, making it unlikely to support life as we know it. Proxima Centauri is a flare star, meaning it experiences sudden and intense bursts of radiation. These stellar flares could pose challenges for life on any planets within its system, as they might strip away atmospheres or irradiate the surface. Challenges of interstellar travel. Despite being the closest star system, traveling to Alpha Centauri is a daunting challenge due to the immense distances involved. At current spacecraft speeds, it would take tens of thousands of years to reach the system. For example, NASA's Voyager 1, traveling at about 38,000 miles per hour, would take over 70,000 years to reach Alpha Centauri. Proposed technologies like the Breakthrough Starshot project aim to send tiny laser-propelled spacecraft to Alpha Centauri at a significant fraction of the speed of light, potentially reducing travel time to just a few decades. Scientific importance of Alpha Centauri. Alpha Centauri holds a special place in the search for life and understanding of planetary systems. Its proximity makes it a prime target for telescopes and future interstellar missions. Scientists hope to study Proxima b and other potential planets for signs of habitability. They also aim to observe the system's dynamics to better understand the formation and evolution of planetary systems. The James Webb Space Telescope, along with other upcoming observatories, may provide more detailed information about the atmospheres and compositions of planets in the Alpha Centauri system. Cultural significance. Alpha Centauri has long captured the human imagination, serving as a backdrop for countless works of science fiction. It represents the closest step on humanity's journey toward exploring the galaxy and symbolizes the vastness and possibilities of the cosmos. In stories and scientific discussions, it often serves as humanity's first destination for interstellar exploration. Conclusion. Alpha Centauri, though just over 4 light-years away, remains tantalizingly out of reach for current space travel capabilities. Its 3-star system, with the promise of potentially habitable planets like Proxima b, continues to inspire astronomers and the public alike. As technology advances, Alpha Centauri will likely play a central role in humanity's quest to reach the stars and uncover the mysteries of the universe.
The International Space Station, humanity's largest and most advanced orbital laboratory, travels at an astounding speed of 5 miles per second, which is approximately 28,000 kilometers per hour or 17,500 miles per hour. This incredible velocity enables the ISS to orbit Earth about once every 90 minutes. allowing its crew to witness 16 sunrises and sunsets every day. The station's rapid speed is crucial for maintaining its orbit and countering the gravitational pull of Earth. The high speed of the ISS is a result of the delicate balance required to maintain orbit around Earth. The ISS is essentially in a state of free fall, continuously falling toward the planet, but moving forward so quickly that it keeps missing the surface. This phenomenon is known as orbital motion. At an altitude of approximately 400 kilometers or 250 miles above Earth's surface, the ISS must travel at this speed to generate sufficient centrifugal force to counteract Earth's gravitational pull. If the ISS were to slow down, it would descend and eventually burn up in the atmosphere. Conversely, if it traveled too fast, it would escape Earth's gravity altogether. The speed of the ISS is governed by the principles of orbital mechanics, specifically Newton's laws of motion and the law of universal gravitation. To stay in a stable low Earth orbit, the ISS must maintain a precise balance between its velocity and the gravitational force acting on it. Gravitational force pulls the ISS toward Earth, while forward velocity ensures that the ISS moves along a curved trajectory, effectively falling around the planet rather than into it. This balance allows the ISS to orbit Earth without the need for continuous propulsion, relying instead on its momentum and occasional adjustments by on-board thrusters to counteract minor drag from the upper atmosphere. Living and working on the ISS at such high speeds is an extraordinary experience for astronauts. From their perspective inside the station, they do not feel the speed because everything around them is moving at the same velocity. However, the effects of the rapid orbit are evident: multiple sunrises and sunsets. The crew experiences a complete day-night cycle every 90 minutes, which can disrupt circadian rhythms. To counter this, astronauts follow a carefully planned schedule based on Coordinated Universal Time, or UTC, rapid travel around the globe. The ISS crosses continents and oceans in mere minutes, allowing astronauts to observe geographical and meteorological phenomena on a global scale. The station's incredible speed also enables it to serve as a unique platform for scientific research, offering opportunities to study microgravity, Earth's atmosphere, and cosmic phenomena in real time. While the ISS's velocity is essential for maintaining orbit, it also presents challenges. Debris hazards. Even small pieces of space debris, traveling at comparable speeds, pose significant risks. The kinetic energy of an object increases exponentially with speed, making even a paint chip potentially destructive. To mitigate this, the ISS is equipped with protective shielding and can perform collision avoidance maneuvers to evade larger debris. Atmospheric drag. Although the ISS orbits above most of Earth's atmosphere, it encounters trace amounts of air particles that create drag and gradually lower its altitude. Periodic reboosts using thrusters or visiting spacecraft help maintain its orbit. The ISS's incredible speed means it crosses the sky in just a few minutes, appearing as a bright, fast-moving point of light. Enthusiasts can track its location using apps or websites to observe it during favorable passes. Its speed and orbit make it one of the most easily visible artificial objects in the night sky. The ISS's rapid speed is not just a technical necessity. It is also symbolic of the cutting-edge collaboration and innovation that the station represents. As an international partnership between agencies like NASA, Roscosmos, ESA, JAXA and CSA, the ISS has become a hub for scientific discovery, technological development and global cooperation. Its velocity reflects humanity's determination to explore and push the boundaries of what is possible in space. Conclusion. Travelling at 5 miles per second, the International Space Station is a marvel of human engineering and scientific achievement. Its speed is essential for maintaining orbit and enables it to serve as a unique platform for research and discovery. Despite the challenges posed by its velocity, the ISS continues to provide invaluable insights into life in space and the universe beyond, inspiring humanity's journey into the cosmos. The Aztecs, one of the most advanced civilizations of pre-Columbian Mesoamerica, held cacao in such high regard that they used it as a form of currency. Cacao beans were more than just food to the Aztecs. They symbolized wealth, power, and divine favor. The beans, harvested from cacao trees, were often traded for goods and services, making them a critical component of the Aztec economy. Cacao's value extended beyond its monetary use. It was also deeply ingrained in Aztec culture and rituals. The Aztecs believed cacao was a gift from the gods, particularly Quetzalcoatl, the feathered serpent deity associated with knowledge and civilization. As a result, cacao was considered sacred and was often reserved for the elite, including rulers, priests, and warriors. It was used in religious ceremonies, where it was prepared as a frothy, bitter drink mixed with spices like chili or annatto, far removed from the sweetened chocolate we know today. The Aztec Empire utilized cacao beans as currency in a structured system. For instance, historical records indicate that 1 cacao bean could buy a tamale, while 100 beans could purchase a turkey. This standardized value allowed cacao to function as a stable medium of exchange, enabling trade across the vast Aztec Empire. Tribute systems also involved cacao, with conquered regions often required to pay taxes in the form of cacao beans, further underscoring their economic importance. The Spanish conquest of the Aztec Empire in the 16th century marked a turning point for cacao. European explorers, including Hernán Cortés, were introduced to the cacao-based drink and recognized its cultural and economic significance. Though the use of cacao as currency declined with the fall of the Aztec Empire, its legacy endured as it became a coveted commodity in Europe, eventually evolving into the chocolate industry we know today. In summary, chocolate's history as currency reflects the ingenuity and cultural richness of the Aztecs. Their use of cacao beans as money underscores the value they placed on this remarkable plant, not just as a source of sustenance, but as a cornerstone of their economy, religion, and social structure.
The miracle berry, scientifically known as Syncephalum dulcificum, is a fascinating fruit native to West Africa. This small red berry has a unique property. It can temporarily alter the way we perceive flavors, making sour or acidic foods taste sweet. This phenomenon is due to a protein called miraculin, which binds to taste receptors on the tongue and modifies their response to acidic substances. When you eat a miracle berry, miraculin interacts with the sweetness receptors on your tongue. Under normal conditions, these receptors are activated only by sugar. However, miraculin changes their behavior in the presence of acidic or sour foods. As a result, when you consume something like a lemon or vinegar after eating the berry, the acid triggers the altered receptors, producing a sweet sensation instead of the expected sour taste. This effect typically lasts for about 30 minutes to an hour, depending on the individual and the amount of miraculin consumed. The miracle berry has been used traditionally in West Africa for centuries, where it was often chewed before meals to improve the taste of otherwise sour or bitter foods. In modern times, the berry has gained popularity in culinary and experimental settings, inspiring flavor-tripping parties where participants explore its ability to transform the taste of various foods. Foods like lemons, limes, grapefruits, and even certain types of cheese and beer become surprisingly sweet when paired with the berry. Aside from its novelty, the miracle berry has also been explored for its potential practical applications. For example, it could serve as a natural sugar substitute for people with diabetes, or those looking to reduce their sugar intake. By making foods taste sweeter without adding actual sugar, miraculin could offer a healthier way to satisfy sweet cravings. Researchers have also investigated its potential use in helping chemotherapy patients, who often experience taste distortions, to better enjoy their food. However, the commercial use of the miracle berry has faced challenges. Attempts to market miraculin as a sugar alternative have been hindered by regulatory and economic barriers, particularly in regions like the United States. The berry itself is delicate and perishable, which complicates large-scale production and distribution. In summary, the miracle berry is a remarkable fruit with the ability to transform how we perceive flavors. Its unique properties not only make it a source of entertainment and curiosity, but also hold promise for health and culinary innovation. While its widespread use remains limited, the miracle berry continues to captivate people worldwide with its extraordinary ability to make the sour taste sweet.
Potato chips, one of the world's most popular snack foods, were famously invented by accident in 1853. The story takes place in Saratoga Springs, New York, at a restaurant called Moon's Lake House, owned by George Crumb, a chef of African-American and Native American descent. Crumb, whose real name was George Speck, unintentionally created the potato chip while trying to appease a particularly picky customer. The legend goes that a diner, commonly believed to be Cornelius Vanderbilt, though this is debated, complained that his fried potatoes were too thick and soggy. In response to the criticism, Crumb decided to make a point by slicing the potatoes impossibly thin, frying them until crisp and seasoning them with salt. To his surprise, the customer loved the result and the dish quickly gained popularity. Originally known as Saratoga chips, the crispy, salty snack became a staple at Moon's Lake House and eventually spread beyond the region. Initially, potato chips were a luxury item, prepared fresh and served in restaurants or sold locally. It wasn't until the early 20th century that chips became a mass-market product. In 1921, Laura Scudder, a California businesswoman, revolutionized the industry by inventing the wax paper bag for chips, which helped preserve their freshness. This innovation, combined with advances in potato chip production and distribution, turned the snack into a household staple. The appeal of potato chips lies in their simplicity: thinly sliced potatoes deep-fried or baked until crispy and seasoned to taste. Over time, their versatility has inspired a vast array of flavors and styles, from classic salted to barbecue sour cream and onion, and even exotic flavors like wasabi or truffle. Potato chips are now produced globally, with billions of bags consumed annually. Despite their humble origins, potato chips have become a cultural phenomenon and a multi-billion-dollar industry. They've inspired national snack holidays, regional flavor competitions, and even debates over the perfect thickness and crunch. While George Crumb couldn't have imagined the worldwide impact of his accidental invention, his contribution to culinary history is undeniable. In summary, potato chips were born from a serendipitous moment in 1853, transforming a simple potato into a beloved snack. From a chef's playful retaliation to a dissatisfied customer, the potato chip's rise to global fame highlights the power of creativity and a little bit of luck.
Some processed cheeses are legally classified as plastic in certain regulatory contexts due to their low dairy content and high levels of additives. This terminology may sound surprising or even unappetizing, but it refers to the food's texture and composition rather than being made of literal plastic. The term is often used in food science and industry regulations to describe cheeses that do not meet the criteria for being classified as real or natural cheese. Processed cheese products, such as cheese slices, spreads and blocks, typically contain less actual dairy than natural cheeses. Instead, they are made by blending cheese with emulsifiers, stabilizers, flavorings and other additives to achieve a uniform texture, extended shelf life and meltability. In some cases, these products contain only a small percentage of real cheese, with the remaining content made up of milk solids, oils and artificial ingredients. This results in a product that doesn't meet the legal or industry standards to be labelled as cheese, leading to classifications like cheese product or, in technical terms, plastic. One example is the widely recognized American cheese, often used in fast food and sandwiches. While marketed as cheese, many of these products are actually pasteurized processed cheese food or pasteurized processed cheese product, depending on their specific composition. The distinction lies in the percentage of real cheese and other dairy ingredients they contain. If the percentage falls below a certain threshold, the product cannot legally be labelled simply as cheese. This classification exists to protect consumers and ensure transparency in food labelling. Regulatory agencies like the US Food and Drug Administration, or FDA, and similar bodies worldwide establish standards for what can and cannot be called cheese. These standards ensure that products labelled as cheese meet specific requirements for milk content, aging and preparation methods. While processed cheese products are sometimes criticised for their artificial ingredients, they remain popular due to their convenience, affordability and versatility. Their ability to melt smoothly makes them ideal for burgers, grilled cheese sandwiches and other dishes requiring a creamy, consistent texture. In summary, the classification of some cheeses as plastic highlights the differences between natural and processed cheese products. While the term might sound unappealing, it reflects the technical aspects of food labelling and composition. These products serve a purpose in modern diets, offering convenience and functionality, though their lower dairy content means they lack some of the qualities of traditional cheeses.
Spam, the iconic canned meat product, is an abbreviation for spiced ham. Introduced by the Hormel Foods Corporation in 1937, Spam was created as a convenient shelf-stable meat option. It consists primarily of pork shoulder and ham, along with a few other ingredients, including salt, water, sugar, potato starch, and sodium nitrite, which helps preserve its freshness and distinctive pink color. Despite its simple composition, Spam has become a globally recognized product with a fascinating history and cultural significance. The name Spam was reportedly chosen during a naming contest held by Hormel. While spiced ham was the inspiration, the actual acronym has been the subject of playful speculation over the years, with some jokingly suggesting it stands for something posing as meat or special processed American meat. However, the official origin remains tied to spiced ham, highlighting its blend of flavors. Spam gained widespread popularity during World War II, when it was included in rations for Allied troops due to its long shelf life and portability. Soldiers became so accustomed to eating Spam that it earned the nickname the meat that won the war. After the war, Spam was introduced to new markets worldwide, particularly in regions like Asia and the Pacific Islands, where it remains a staple in local cuisines. In Hawaii, Spam has become deeply ingrained in the culinary culture, with dishes like Spam musubi, a sushi-style snack made with Spam, rice and seaweed, being especially popular. Hawaii consumes more Spam per capita than any other state, earning it the title of the Spam capital of the world. Other countries, such as South Korea, the Philippines and Japan, also embrace Spam in various recipes, from stews to fried rice. Over the years, Spam's reputation has fluctuated. While some view it as a nostalgic comfort food, others criticize it for being overly processed or associated with economic hardship. Nevertheless, Spam has endured as a cultural phenomenon, inspiring festivals like the annual Spam Jam in Hawaii, and even earning a spot in the Smithsonian's National Museum of American History. Spam's longevity and versatility can be attributed to its adaptability in both traditional and modern recipes. Its affordability and convenience have made it a pantry staple for generations. Whether fried for breakfast, served in a sandwich, or incorporated into gourmet dishes, Spam continues to hold a unique place in the global culinary landscape. In summary, Spam, short for spiced ham, has evolved from a wartime necessity to a beloved and sometimes polarizing food icon. Its blend of simplicity, utility, and cultural significance ensures that it remains a recognizable and enduring product worldwide.
The Scoville scale is a widely recognized system used to measure the heat or spiciness of chili peppers and other spicy foods. Developed in 1912 by American pharmacist Wilbur Scoville, the scale quantifies the concentration of capsaicin, the compound responsible for the burning sensation associated with peppers. Capsaicin stimulates pain receptors in the mouth, producing the characteristic heat that ranges from mild warmth to intense, fiery spice. The scale is expressed in Scoville heat units, or SHUs, which represent the amount of capsaicin present. For example, a sweet bell pepper, which has no heat, scores 0 SHUs, while a jalapeno pepper ranges from 2,500 to 8,000 SHUs. At the higher end of the scale are extremely hot peppers, like the Carolina Reaper, which averages over 1.6 million SHUs and holds the Guinness World Record for the hottest chili pepper. Originally, Scoville's method involved diluting an extract of a pepper in sugar water and having a panel of tasters sample the mixture. The dilution continued until the heat was no longer detectable, and the degree of dilution determined the SHU rating. While groundbreaking for its time, this method was subjective, as it relied on human taste perception, which can vary between individuals. Today, the Scoville scale is determined using more objective scientific methods, such as high-performance liquid chromatography, or HPLC. This technique measures the exact concentration of capsaicinoids in a pepper and translates that measurement into SHUs. Modern technology has made the process more precise and reliable, though the original Scoville scale remains the standard for describing pepper heat. The Scoville scale has become an essential tool for chili enthusiasts, chefs, and food manufacturers. It helps consumers understand the heat level of peppers and spicy products, aiding in everything from recipe creation to competitive eating challenges. Additionally, it plays a role in non-culinary applications, as capsaicin is used in products like pepper spray for self-defense and in topical pain relief creams. In summary, the Scoville scale is an enduring and invaluable method for quantifying the spiciness of peppers and other foods. From its humble beginnings as a subjective taste test to its modern scientific applications, the scale has shaped how we understand and enjoy spicy flavors, making it a staple in both culinary and scientific contexts.
Vanilla flavoring, especially in its synthetic form, has occasionally been associated with castoreum, a compound derived from the castor sacs of beavers. These sacs, located near the base of a beaver's tail, produce a substance that beavers use for marking their territory. Castoreum has a musky, slightly sweet aroma, which has historically made it a useful ingredient in perfumes and flavorings, including vanilla, raspberry and strawberry. Castoreum's use in food flavoring has been documented for centuries, but its presence is far less common today. The compound is classified as a natural flavoring by the US Food and Drug Administration, FDA, meaning it can legally be included in foods without explicit labeling. However, its use in food is extremely rare due to the expense and difficulty of harvesting castoreum. Extracting the substance requires anesthetizing and carefully milking the beaver's castor sacs, a labor-intensive process that makes it impractical for large-scale food production. Most vanilla flavoring today comes from either natural vanilla beans or synthetic vanillin, the primary flavor compound in vanilla. Synthetic vanillin is typically derived from guaiacol, a compound found in wood or other sources like clove oil or lignin, a byproduct of the wood pulp industry. These methods are far more cost-effective and scalable than using castoreum, making them the preferred options for the food and beverage industry. While the idea of castoreum in vanilla flavoring often sparks curiosity or even alarm, its actual usage is negligible in modern food production. When used, it's typically reserved for high-end perfumes or specialty products rather than everyday foods. In fact, most people will never encounter castoreum in their vanilla-flavored products, as synthetic and natural vanilla are overwhelmingly dominant in the market. In summary, while castoreum has an intriguing historical connection to vanilla flavoring, its use is now extremely rare due to the high cost and ethical considerations of harvesting it. Advances in synthetic flavor production and widespread cultivation of vanilla beans have made castoreum virtually obsolete in the food industry, ensuring that your favorite vanilla-flavored treats are more likely derived from plant-based or lab-produced sources.
Watermelon is a fascinating plant that is classified as both a fruit and a vegetable, depending on the context and perspective. Scientifically, watermelon, or Citrullus lanatus, is a fruit because it develops from the flowering ovary of the plant and contains seeds, fitting the botanical definition of a fruit. However, culturally and agriculturally, watermelon is often considered a vegetable because it belongs to the Cucurbitaceae family, which includes cucumbers, squash and pumpkins, all of which are typically classified as vegetables. Watermelon's dual classification arises from its growth habits and usage. Like other vegetables, watermelons are planted, cultivated, and harvested as part of the annual farming cycle. In fact, the state of Oklahoma officially recognizes watermelon as its state vegetable, highlighting its cultural and agricultural ties to vegetable farming practices. This classification emphasizes its role in agricultural systems, particularly in regions where it is grown alongside other vegetable crops. From a culinary standpoint, watermelon is most commonly treated as a fruit because of its sweet, juicy flesh. It's a staple in desserts, salads and beverages, making it a quintessential summer treat. The high water content, about 92%, and natural sweetness of watermelon make it ideal for refreshing dishes, while its versatility allows it to be paired with savory ingredients like feta cheese or mint. Historically, watermelon is believed to have originated in Africa and was first domesticated thousands of years ago. Early varieties were cultivated not only for their sweet flavor but also as a source of hydration in arid climates. Over time, selective breeding has enhanced the sweetness and reduced the bitterness of modern watermelons, solidifying their place as a popular fruit worldwide. Watermelons are also nutritionally valuable, rich in vitamins A and C, antioxidants like lycopene, and hydrating electrolytes. Both the flesh and the rind are edible, with the rind often used in pickling or stir-fry dishes, particularly in some Asian cuisines. This wide range of uses underscores watermelon's versatility as both a fruit and a vegetable. In summary, watermelon occupies a unique space in the plant kingdom, straddling the line between fruit and vegetable. Its botanical identity as a fruit and its agricultural and cultural ties to vegetables make it a rare example of how food classifications can overlap. Whether enjoyed as a sweet dessert or incorporated into savory dishes, watermelon remains a universally beloved food with a rich history and diverse applications.
Tomatoes, one of the most popular and versatile fruits in the world today, were once known as love apples. This name likely originated from the French term pomme d'amour, which translates to apple of love. The term reflects both the tomato's exotic origins and its early reputation as a symbol of romance and allure, particularly in Europe during the Renaissance and early modern periods. The association of tomatoes with love may have been influenced by their introduction to Europe in the 16th century. Tomatoes were brought from the Americas, where they were first cultivated by the Aztecs and other indigenous peoples, to Spain and then spread across Europe. Their vibrant red color, juicy texture and somewhat heart-like shape made them stand out as an unusual and appealing fruit. These characteristics, combined with their novelty, likely contributed to their romantic nickname. Additionally, there was a time when tomatoes were believed to have aphrodisiac properties. This belief, though not scientifically supported, enhanced their reputation as love apples. The exotic and mysterious nature of the tomato during its early days in Europe added to its allure, and its cultivation was initially limited to ornamental gardens rather than widespread culinary use. For centuries, tomatoes were met with suspicion and even fear in some parts of Europe. Many people believed they were poisonous due to their resemblance to deadly nightshade plants, which are also part of the Solanaceae family. This association likely delayed their acceptance as a food source. Over time, however, people began to recognize their culinary value, and they became a staple ingredient in Mediterranean and Italian cuisines. By the 18th century, the love apple's reputation shifted from mystery and romance to practicality and widespread enjoyment. Tomatoes became a key ingredient in dishes like pasta sauces, soups, and salads, earning their place as a dietary staple. Today, the romantic moniker love apple has faded into history, but it remains a charming reminder of the tomato's fascinating journey from an exotic curiosity to a global food icon. In summary, the term love apple reflects the tomato's early European history as an exotic and intriguing fruit with romantic associations. While it is now celebrated for its culinary versatility and nutritional value, the nickname serves as a glimpse into the cultural perceptions of the tomato during a time of discovery and exploration.
One of the world's most unusual and expensive coffees, known as civet coffee or Kopi Luwak, is made from coffee beans that have been eaten and excreted by civet cats. The process begins when a civet, a small nocturnal mammal native to Southeast Asia, consumes ripe coffee cherries. As the cherries pass through the civet's digestive system, enzymes in its stomach break down certain proteins in the beans, reducing their bitterness and imparting a unique flavor profile. After the beans are excreted, they are collected, thoroughly cleaned and roasted to create a smooth aromatic coffee with a distinctive taste. Kopi Luwak is often described as having a rich, earthy flavor with hints of caramel or chocolate. Its unique production process and scarcity have made it one of the most expensive coffees in the world, often selling for hundreds of dollars per pound. Civet coffee originated in Indonesia during the Dutch colonial period. Local farmers were prohibited from using coffee grown on colonial plantations, so they began collecting partially digested beans from civet droppings to process and brew their own coffee. Over time, the practice gained recognition for the coffee's unique taste, and Kopi Luwak eventually became a sought-after luxury product. However, the popularity of civet coffee has raised significant ethical and environmental concerns. In many cases, civets are kept in captivity under poor conditions and force-fed coffee cherries to produce beans on a commercial scale. This practice is harmful to the animals and undermines the original natural process that made Kopi Luwak unique. As a result, animal welfare advocates and ethical coffee consumers often encourage people to avoid commercially farmed civet coffee and instead support more sustainable and humane alternatives. In addition to ethical issues, the high price of Kopi Luwak has led to counterfeit products and fraudulent labeling. Some coffees sold as civet coffee are not produced using the traditional process, and consumers are often unable to verify their authenticity. This has further complicated the market for genuine Kopi Luwak. In summary, Kopi Luwak is a coffee made from beans that have been eaten and excreted by civet cats, offering a unique flavor that results from enzymatic digestion. While it is a fascinating and historically significant product, its popularity has led to ethical and environmental challenges. Consumers interested in trying civet coffee are encouraged to seek out ethically sourced options or explore other premium coffee varieties with similar flavor profiles.
The The Sahara Desert, one of the hottest and most arid places on Earth, is known for its extreme temperature fluctuations. While daytime temperatures can soar above 120 degrees Fahrenheit, nighttime temperatures can drop dramatically, sometimes reaching freezing levels. This drastic change occurs due to the desert's unique climate, geography, and lack of moisture in the air. One of the main reasons for these extreme temperature shifts is the low humidity in the Sahara. Deserts typically have very little water vapor in the atmosphere, which means they lack the ability to retain heat. During the day, the sun's intense radiation heats up the sand and rocks, causing scorching temperatures. However, once the sun sets, there is nothing to trap the heat, so it quickly radiates back into the atmosphere, leading to rapid cooling. Another factor contributing to the freezing nighttime temperatures is the lack of cloud cover. In more humid climates, clouds act as insulation, helping to retain some of the heat absorbed during the day. In the Sahara, clear skies allow for an uninterrupted escape of heat, causing temperatures to plummet overnight. Although freezing temperatures are not a daily occurrence, they are common in certain areas of the Sahara, especially during the winter months. Some regions, particularly in higher elevations, have even recorded snowfall, a rare but not unheard of phenomenon. In 1979, for instance, a brief snowstorm was reported in southern Algeria, and in recent years, parts of the Sahara have experienced occasional light snow. Despite these cold nights, desert animals and plants have adapted to survive these extreme conditions. Many desert creatures, such as fennec foxes and jerboas, are nocturnal, meaning they rest during the scorching day and become active at night when temperatures are cooler. Some plants, like cacti and succulents, store water to endure both the heat of the day and the chill of the night. In summary, the Sahara Desert's ability to reach freezing temperatures at night is a direct result of its dry climate, lack of moisture, and clear skies. These extreme temperature swings create a harsh yet fascinating environment where life has evolved to withstand both the intense heat of the day and the unexpected cold of the night.
Canada is home to approximately 60% of the world's polar bear population, making it the most important habitat for these iconic Arctic predators. With an estimated 16,000 of the global 26,000 polar bears residing in Canadian territory, the country plays a crucial role in their conservation and survival. These majestic creatures primarily inhabit the coastal areas of the Arctic, where they rely on sea ice to hunt, travel, and raise their young. The majority of Canada's polar bears are found in Nunavut, Manitoba, the Northwest Territories, Quebec, and Ontario, with notable populations along Hudson Bay, Baffin Island, and the Beaufort Sea. One of the most famous polar bear hotspots is Churchill, Manitoba, often called the polar bear capital of the world. Each fall, hundreds of polar bears gather near the town, waiting for the sea ice to form so they can begin their annual seal hunting season. This migration attracts thousands of tourists and researchers eager to observe the bears in their natural habitat. Polar bears are highly dependent on sea ice, which they use as a platform to hunt their primary prey, seals. They are uniquely adapted to Arctic conditions, with thick fur, a layer of insulating fat, and large paws that help them navigate the icy terrain. However, climate change poses a significant threat to their survival. Rising global temperatures are causing the Arctic ice to melt at an alarming rate, reducing the time polar bears can spend hunting and forcing them to travel greater distances in search of food. This has led to increasing instances of malnutrition, lower birth rates, and more frequent encounters between polar bears and humans as the bears venture inland in search of sustenance. Canada has implemented various conservation efforts to protect its polar bear populations. These include hunting regulations, habitat protection, and partnerships with indigenous communities who have traditionally coexisted with polar bears and play a key role in conservation efforts. Many indigenous groups, such as the Inuit, hold deep cultural and spiritual connections with polar bears and advocate for sustainable management practices that balance conservation with traditional hunting rights. In summary, Canada's vast Arctic landscapes provide a critical habitat for the majority of the world's polar bears. While the country is leading efforts to protect these animals, the ongoing challenges of climate change and habitat loss highlight the urgent need for continued conservation and global action to ensure the survival of this magnificent species.
The Pacific Ocean is the largest and deepest ocean on Earth, covering an area of approximately 63 million square miles, which is about 165 million square kilometers. This makes it larger than all the land masses on Earth combined, which collectively total about 57.5 million square miles or 149 million square kilometers. In other words, if all the continents were put together, they would still not match the sheer size of the Pacific Ocean. This immense body of water spans from the Arctic in the north to the Southern Ocean in the south and stretches between the continents of Asia, Australia, North America and South America. The Pacific Ocean plays a critical role in regulating the planet's climate, as it covers nearly 1/3 of Earth's surface. Its vast expanse absorbs and distributes heat, helping to moderate global temperatures and influence weather patterns. The ocean is home to some of the most significant climate phenomena, including El Niño and La Niña, which affect global rainfall, hurricanes, and agricultural cycles. Additionally, the Pacific's deep waters store a significant amount of carbon dioxide, making it an essential component of Earth's carbon cycle. One of the most remarkable aspects of the Pacific is its depth. The ocean contains the Mariana Trench, the deepest part of the world's oceans, which plunges down to about 36,000 feet or 11,000 meters in the Challenger Deep. This depth is so extreme that if Mount Everest, the tallest mountain on Earth, were placed inside the trench, it would still be submerged by more than a mile of water. The Pacific also contains thousands of islands, including entire nations such as Hawaii, the Philippines and Fiji, as well as some of the most remote places on Earth. Historically, the Pacific Ocean has been vital for human exploration, trade and cultural exchange. Ancient Polynesians navigated its vast waters using the stars, winds and ocean currents, settling islands thousands of miles apart. Later, European explorers such as Ferdinand Magellan crossed the Pacific during the Age of Exploration, leading to increased global trade and interaction. Today, the Pacific remains a major economic and geopolitical region, with its waters supporting global shipping routes, fisheries and vast natural resources. Despite its size and significance, the Pacific Ocean faces numerous environmental challenges, including climate change, overfishing and pollution. One of the most well-known ecological concerns is the Great Pacific Garbage Patch, a massive accumulation of plastic debris caught in the ocean's currents. Rising sea levels also threaten many low-lying Pacific islands, putting their inhabitants at risk of displacement. In summary, the Pacific Ocean is a vast and crucial part of our planet, covering more area than all the continents combined. It influences global climate, supports diverse marine life, and has played a key role in human history. However, its immense size does not make it immune to environmental threats, highlighting the need for global efforts to protect and preserve this incredible ocean for future generations.
Russia, the largest country in the world by land area, spans a staggering 11 time zones, making it the most time zone spanning nation on Earth. Stretching across over 5,600 miles, or 9,000 kilometers, from its westernmost point in Kaliningrad to its easternmost point near the Bering Strait, Russia covers nearly half of the planet's longitudinal span. This vast expanse means that when one part of the country is experiencing sunrise, another may be in the middle of the night. The 11 time zones of Russia range from Kaliningrad time, which is UTC+2 in the west, to Kamchatka time, which is UTC+12 in the far east. Major cities like Moscow and St. Petersburg follow Moscow time, which is UTC+3. while regions in Siberia and the Russian Far East, such as Vladivostok and Petropavlovsk-Kamchatsky, observe much later time zones. This wide geographical spread presents logistical challenges, as businesses, government operations, and communication between different regions must accommodate significant time differences. Historically, Russia had more than 11 time zones, but in 2010, the government reduced the number to 9 to simplify administration. However, in 2014, some of the eliminated time zones were restored, bringing the count back to 11. The country does not observe daylight saving time, after abandoning the practice in 2011, keeping its clocks consistent year-round. The sheer number of time zones affects everyday life in Russia in unique ways. For example, when financial markets open in Moscow, traders in the Russian Far East have already ended their workday. Similarly, travelers moving across the country by the Trans-Siberian Railway, which takes about a week to cross Russia, experience multiple time changes along their journey. Even national television programming and sports broadcasts must carefully account for the vast time differences between regions. Despite the challenges, Russia's 11 time zones reflect its immense geographic and cultural diversity, from the bustling metropolises of Moscow and St. Petersburg to the remote wilderness of Siberia and the Pacific coastline. The country's time zones represent its vast and varied landscape. Russia's unique position as a bridge between Europe and Asia makes it a fascinating example of how time and geography shape a nation's identity and daily life.
The Nile River is one of the most famous and historically significant rivers in the world. Stretching approximately 4,135 miles, it is often considered the longest river on Earth, though some debate exists regarding whether the Amazon River might be longer. The Nile flows through 11 countries in northeastern Africa, including Egypt, Sudan, South Sudan, Ethiopia, and Uganda, before emptying into the Mediterranean Sea. Despite originating from sources in Central and Eastern Africa, the Nile follows a northward course, which is unusual as most major rivers tend to flow southward or eastward due to gravitational pull and land elevation patterns. The Nile's northward flow is primarily due to the topography of Africa. The river originates from high-altitude sources such as Lake Victoria and the Ethiopian highlands and moves toward lower elevations in the north. While many people assume that rivers always flow south, the truth is that rivers simply follow the path of least resistance, moving from higher to lower elevations rather than adhering to a specific cardinal direction. Since the land in East and Central Africa is significantly higher than the terrain near the Mediterranean, the Nile naturally flows northward. Another unique aspect of the Nile is its immense historical and cultural significance. Ancient Egypt, one of the world's greatest civilizations, relied heavily on the river for agriculture, trade, and daily life. The predictable annual flooding of the Nile deposited nutrient-rich silt onto the surrounding land, making it incredibly fertile for farming. This agricultural prosperity enabled the rise of Egypt's great cities, temples, and pyramids, and the river was deeply ingrained in Egyptian mythology and religion. The Nile River consists of two major tributaries, the White Nile and the Blue Nile. The White Nile, considered the primary and longer branch, originates in East Africa, while the Blue Nile, which provides the majority of the river's water and sediment, starts in the Ethiopian highlands. The two rivers converge in Khartoum, Sudan, and continue their journey northward as a single mighty river. Despite its historical importance, the Nile faces numerous modern challenges, including disputes over water rights, climate change, and pollution. Countries along its path, especially Egypt, Sudan, and Ethiopia, have been engaged in tense negotiations regarding the construction of dams, such as the Grand Ethiopian Renaissance Dam, which has raised concerns about water access and agricultural sustainability in downstream nations. Ultimately, the Nile's northward flow is a fascinating geographical anomaly, but more importantly, it has been a lifeline for civilizations for thousands of years. Its waters have shaped history, supported countless communities, and continue to play a crucial role in the economy and survival of millions of people today.
Antarctica has no official time zone, making it one of the most unique places on Earth in terms of timekeeping. Unlike other continents, which are divided into distinct time zones based on longitudinal divisions, Antarctica lacks a permanent human population and does not belong to any single country. Because of this, there is no universally recognized time zone assigned to the continent. Instead, timekeeping in Antarctica is determined by the research stations and expeditions operating there, each of which follows a time zone based on convenience rather than geography. One of the main reasons Antarctica lacks an official time zone is its location at the South Pole, where lines of longitude converge. This means that technically every time zone on Earth exists in Antarctica at once. However, since Antarctica is largely uninhabited except for scientists and researchers, it does not follow a structured time system like other continents. Instead, different research stations and bases use time zones based on their home countries or the locations from which they receive supplies. For example, the McMurdo Station, operated by the United States, follows New Zealand Standard Time because supply flights often come from Christchurch, New Zealand. Another factor that complicates timekeeping in Antarctica is its extreme day-night cycles. During the Antarctic summer, which runs from October to March, the continent experiences 24 hours of daylight. Conversely, in the Antarctic winter, from April to September, it faces months of continuous darkness. Because of this, traditional timekeeping based on the movement of the sun becomes meaningless. It's more practical for research stations to align with their home countries or logistical hubs. Different countries operating in Antarctica set their own time zones for their research stations. For example, Argentina and Chile use UTC-3, while Russia's Vostok station follows Moscow Standard Time, which is UTC +3 or +5, depending on daylight saving time in Russia. Some stations adjust their clocks to match nearby supply bases, while others stick to Coordinated Universal Time or UTC to avoid confusion. The lack of an official time zone in Antarctica has minimal impact on daily operations, as scientific research and expeditions follow schedules set by their respective organizations. However, it does create an interesting anomaly in global timekeeping, making Antarctica one of the few places on Earth where time is entirely subjective and flexible.
Greenland is a fascinating geographical anomaly because it extends farther north, south, east and west than Iceland, making it unique in its positioning. At first glance, this may seem counterintuitive, given that both Greenland and Iceland are relatively close in the North Atlantic. However, Greenland's sheer size, it is the world's largest island, allows it to stretch across a vast range of latitudes and longitudes, surpassing Iceland in all four cardinal directions. Greenland's northernmost point is Cape Morris Jesup, which lies at 83.6 degrees north, just 440 miles from the North Pole. In contrast, Iceland's northernmost point, Kolbeinsey, is located at 67.1 degrees north, far to the south. This difference is significant as it places Greenland much closer to the Arctic and within the realm of extreme polar conditions, while Iceland remains relatively milder due to the warming influence of the Gulf Stream. Although Greenland is often associated with the Arctic, its southernmost tip, Cape Farewell, extends down to 59.8 degrees north. This is actually farther south than Reykjavik, Iceland's capital, which sits at 64.1 degrees north. While much of Greenland remains covered in ice, its southern regions, particularly near the coast, experience a more temperate climate during the summer months. Greenland's easternmost point is Nordastrundingen, located at 11.3 degrees west. In comparison, Iceland's easternmost point, Gerpir, sits at 13.5 degrees west. This means that despite Iceland being farther east overall, Greenland's vast landmass extends slightly beyond Iceland's easternmost reach. Greenland's westernmost point, Cape Alexander, is located at 73.1 degrees west, significantly farther west than Iceland's westernmost point, Bjartanga, at 24.5 degrees west. This makes Greenland extend much deeper into the Western Hemisphere, emphasizing its size and geographical dominance in the region. Greenland's vast range in all four directions highlights its enormous geographical scale compared to Iceland. Although both lands are known for their cold climates and Viking history, Greenland's position gives it a much wider variety of weather conditions, ecosystems, and daylight variations throughout the year. Iceland, in contrast, remains more centrally located in the North Atlantic and enjoys a more moderate climate due to ocean currents. This fun geographical fact serves as a reminder of how size and location influence a country's climate, geography, and even its historical development. Despite being closely associated with the Arctic, Greenland's landmass extends into regions that would be considered subarctic or even temperate, making it one of the most geographically diverse islands on Earth.
The Dead Sea, the lowest point on Earth. The Dead Sea is the lowest point on Earth's surface, sitting at approximately 430 meters or 1,410 feet below sea level. Located between Jordan to the east and Israel and Palestine to the west, this hyper-saline lake is one of the most unique natural wonders in the world. Its extreme low elevation makes it a geographical marvel, as no other place on land reaches such depths below sea level. The Dead Sea continues to shrink due to evaporation and water diversion, causing its shoreline to drop even further each year. Why is the Dead Sea so low? The Dead Sea is part of the Jordan Rift Valley, a geological depression formed by the movement of tectonic plates. It lies within the Dead Sea Transform fault system, where the Arabian Plate and the African Plate are slowly pulling apart. Over millions of years, this rift has caused the land to sink, creating one of the lowest basins on Earth. Unlike oceans and other bodies of water that connect to larger waterways, the Dead Sea has no outlet, meaning water only leaves through evaporation. This contributes to its extreme salinity and the continuous lowering of its surface level. The saltiest body of water. With a salinity of about 34%, the Dead Sea is nearly 10 times saltier than the ocean, making it one of the saltiest bodies of water on the planet. This high salt concentration makes it impossible for most aquatic life to survive, which is how the Dead Sea got its name. The extreme salinity also gives it a famous property, natural buoyancy. People can easily float on its surface without any effort, as the dense water provides greater lift than ordinary seawater. Health and historical significance. The Dead Sea has been renowned for its healing properties for thousands of years. The unique mineral composition of the water, including magnesium, potassium, and calcium, is believed to have therapeutic benefits for skin conditions like psoriasis and arthritis. Ancient civilizations, including the Egyptians and Romans, highly valued Dead Sea minerals for medicinal and cosmetic purposes. Even Cleopatra, the famous Egyptian queen, was said to have used Dead Sea products for skincare. Environmental challenges. The Dead Sea is shrinking rapidly due to human activities and climate change. The diversion of water from the Jordan River, which is its main water source, has significantly reduced the amount of fresh water reaching the sea. As a result, the water level is dropping at a rate of more than 1 meter, or 3 feet, per year. Large sinkholes have also begun appearing around the shoreline, posing a risk to infrastructure and tourism. Efforts are being made to preserve the Dead Sea, including discussions about building a canal from the Red Sea or the Mediterranean to restore water levels. A geological and cultural wonder. Beyond being the lowest point on Earth, the Dead Sea is a place of immense historical, religious, and geological significance. It is mentioned in ancient texts, including the Bible, and remains a major attraction for scientists, tourists, and wellness seekers. Its surreal landscape, with its salt-crusted shores and shimmering blue waters, makes it one of the most extraordinary places on the planet. Whether for its natural beauty, unique properties, or historical importance, the Dead Sea remains a remarkable and fragile wonder of the world.
Monaco, the tiny country smaller than Central Park. Monaco, the second smallest country in the world, is famous for its luxury, wealth and grand casinos. But one of its most surprising facts is its tiny size. Just 2.1 square kilometers or 0.81 square miles. This means that the entire country of Monaco is smaller than Central Park in New York City, which spans 3.41 square kilometers or 1.32 square miles. Despite its small size, Monaco is one of the most densely populated and wealthiest nations in the world. A tiny nation packed with luxury. Monaco is located on the French Riviera, bordered by France on 3 sides and the Mediterranean Sea to the south. Despite its size, Monaco is a global hub for high-end tourism, banking and entertainment. It is best known for the Monte Carlo Casino, the Monaco Grand Prix, and its status as a tax haven. The country has a population of around 40,000 people, making it one of the most densely populated places on Earth. With land being incredibly scarce, Monaco has expanded through land reclamation projects, adding more space along the coast. Central Park versus Monaco, a size comparison. Central Park, a large urban park in the heart of Manhattan, is bigger than Monaco in terms of land area, covering 843 acres compared to Monaco's 519 acres. Central Park serves as a green oasis within a bustling city, while Monaco is a densely built-up area filled with skyscrapers, luxury apartments and high-end shops. However, despite being smaller, Monaco functions as an independent sovereign nation, complete with its own government, monarchy and economy, whereas Central Park is simply a section of New York City. Monaco's small size does not limit its global influence. It is famous for attracting billionaires, celebrities and royalty, largely due to its no-income tax policy and luxurious lifestyle. Property prices in Monaco are among the highest in the world, with real estate often selling for over $50,000 per square metre. The country hosts major international events such as the Monaco Grand Prix, one of the most prestigious Formula One races, and the Monaco Yacht Show, attracting the world's elite. Though Monaco is smaller than Central Park, it operates as a fully independent country with a booming economy, an influential cultural scene, and a reputation for extreme wealth and exclusivity. This comparison highlights just how compact Monaco is, proving that size does not determine global impact. Despite its tiny footprint, Monaco remains one of the most glamorous and intriguing places in the world.
Deep in the Karakum Desert of Turkmenistan lies a massive fiery crater known as the Door to Hell. This surreal burning pit, officially called the Darvaza gas crater, has been burning continuously for over 50 years. It is one of the most unusual and eerie natural phenomena in the world, drawing scientists, adventurers and curious travelers to witness its unearthly glow. The Darvaza gas crater was not a naturally occurring phenomenon. It was actually created by accident in 1971 during a Soviet drilling operation. Soviet geologists were exploring the Karakum Desert for natural gas reserves when they unintentionally punctured an underground gas pocket, causing the ground to collapse. This resulted in a 70-meter, 230 feet wide, and 30-meter, 98 feet deep crater, from which large amounts of methane gas began leaking into the air. To prevent the spread of toxic methane gas, the geologists decided to set the crater on fire, assuming the gas would burn off within a few weeks. However, instead of extinguishing quickly, the fire has continued to burn for over 5 decades. Fueled by the vast natural gas reserves beneath the desert, scientists are still uncertain how much gas remains, or when the flames will eventually die out. Despite its dangerous and eerie appearance, the Door to Hell has become one of Turkmenistan's most famous tourist attractions. The flames burn day and night, creating an otherworldly glow that can be seen from miles away, especially in the dark. Tourists and explorers travel to the remote site to witness the blazing inferno, making it a symbol of the country's vast and largely untapped natural gas resources. Although the burning crater has fascinated visitors for years, the Turkmen government has expressed concerns over its environmental impact and waste of valuable natural gas. In 2022, Turkmenistan's President Gurbanguly Berdimuhamedov announced plans to find a way to extinguish the fire and seal the crater. However, given the crater's history and the difficulty of stopping the underground gas flow, no successful attempt has been made so far. The door to hell remains one of the most bizarre and visually stunning landmarks on Earth. What started as a failed Soviet drilling project has turned into a permanent fire pit, capturing global attention and reminding us of the unpredictable power of nature. Whether it continues to burn for another 50 years or is eventually extinguished, the Darvaza gas crater will remain an extraordinary part of Turkmenistan's landscape and history.
To make you question everything you thought you knew.
One of the most surprising facts in the world of film and television is that the legendary voice of Yoda from Star Wars is also the voice behind Miss Piggy from The Muppets. Both characters were brought to life by the incredibly talented Frank Oz, a puppeteer, director and voice actor whose work has shaped some of the most beloved franchises in entertainment history. Born in 1944, Frank Oz, born Frank Richard Osnowitz, began his career as a puppeteer working with Jim Henson, the creator of The Muppets. He quickly became a key member of the Muppets team, performing some of the most famous characters, including Miss Piggy, Fozzie Bear, Animal and Sam the Eagle. His ability to bring distinct personalities to life through voice and movement made him one of the most respected puppeteers in the industry. In 1980, Oz was chosen by Star Wars creator George Lucas to voice and perform Yoda, the wise and ancient Jedi Master who first appeared in The Empire Strikes Back. Using his puppeteering skills, Oz gave Yoda a unique speech pattern, wise yet humorous mannerisms, and a voice that became instantly recognizable. His performance helped make Yoda one of the most iconic and beloved characters in the Star Wars universe. And Miss Piggy, one of the Muppets' most famous characters, is a bold, glamorous and sometimes temperamental pig who is madly in love with Kermit the Frog. Oz gave her a strong and dramatic voice, full of sass, confidence and comedic timing. She became a fan favorite due to her larger-than-life personality and famous karate chops. While Yoda and Miss Piggy are vastly different characters, one a wise and ancient Jedi Master and the other a fashion-forward, dramatic diver, Frank Oz managed to bring both to life in a way that made them instantly memorable. Yoda's gravelly, philosophical tone contrasts sharply with Miss Piggy's high-pitched, demanding voice, showcasing Oz's incredible range as a voice actor. Beyond Yoda and Miss Piggy, Frank Oz has had a remarkable career as a director and performer. He has directed several films, including The Dark Crystal, The Muppets Take Manhattan, Little Shop of Horrors, and Dirty Rotten Scoundrels. His contributions to both Star Wars and The Muppets have made him a legend in the world of puppetry and film. It's hard to believe that the same person who gave us Yoda's calm wisdom also created Miss Piggy's over-the-top personality. Frank Oz's incredible talent for voice acting and puppeteering has left an unforgettable mark on pop culture. Whether you're watching a Star Wars film or a Muppet show, chances are you're hearing the work of a true master of his craft.
The Simpsons holds the record as the longest-running scripted television show in history, a title it has maintained for decades. Premiering on December 17, 1989, the animated sitcom created by Matt Groening has become a cultural phenomenon, influencing generations of viewers, comedians and television writers. With over 750 episodes and counting, the show continues to entertain audiences with its satirical take on American life. Before becoming a full-fledged series, The Simpsons started as a series of short animated sketches on The Tracey Ullman Show in 1987. These brief clips introduced the world to Homer, Marge, Bart, Lisa and Maggie Simpson, a dysfunctional yet lovable family living in the fictional town of Springfield. Due to their popularity, Fox executives decided to develop the shorts into a standalone show, which officially debuted in 1989. Since its debut, The Simpsons has shattered multiple records. It became the longest-running American primetime animated series and surpassed Gunsmoke in 2018 as the longest-running scripted primetime TV series. With more than 35 seasons, the show has remained a staple of television history, influencing countless other animated series like Family Guy, South Park and Rick and Morty. Beyond its longevity, The Simpsons has had a profound cultural impact. The show's characters, catchphrases and satirical humour have become embedded in pop culture. Lines like "Dough," Homer's signature exclamation, and "Eat my shorts," Bart's rebellious catchphrase, are instantly recognisable worldwide. Additionally, The Simpsons has been credited with predicting real-world events, including Donald Trump's presidency, smartwatches, and even the Disney-Fox merger. One of the biggest reasons for The Simpsons' longevity is its ability to evolve with the times. The show continuously updates its humour to reflect current events, pop culture trends and changing social attitudes. With a massive rotating cast of guest stars, including politicians, musicians and Hollywood celebrities, the series keeps itself relevant while maintaining its classic humour and charm. Despite its historic success, The Simpsons has faced criticism over the years. Many fans argue that the earlier seasons, particularly seasons 3 to 10, were the show's golden age, while later seasons have struggled to maintain the same sharp writing and cultural significance. Additionally, the portrayal of certain characters, such as Apu Nahasapima Petilon, has sparked debates about representation in media. Still, the show's fan base remains strong, and it continues to draw millions of viewers worldwide. With over 35 seasons, a feature film, The Simpsons movie released in 2007, and dozens of awards, The Simpsons is more than just a TV show. It's a global phenomenon. It has shaped the landscape of television comedy, paving the way for animated sitcoms and pushing the boundaries of satire. Whether it continues for another decade or eventually comes to an end, The Simpsons has already cemented its place in television history as the longest-running and one of the most influential scripted TV shows of all time.
On April 23, 2005, a historic moment in internet history took place. The first ever YouTube video was uploaded. Titled "Me at the Zoo," the 18-second clip features Jord Karim, one of YouTube's co-founders, standing in front of elephants at the San Diego Zoo. While it may seem like a simple and unremarkable video, this upload marked the beginning of what would become one of the largest and most influential platforms in the world. YouTube was founded by Jord Karim, Steve Chen and Chad Hurley, three former PayPal employees who wanted to create an easy way for people to upload and share videos online. At the time, there were very few user-friendly platforms for sharing video content. Inspired by the challenges of finding and posting videos online, the trio launched YouTube.com on February 14, 2005, and a couple of months later, Me at the Zoo became its first upload. The video itself is simple and casual. Jord Karim stands in front of elephants at the San Diego Zoo and briefly talks about their really long trunks. While it may not seem groundbreaking, this short clip symbolized the start of a new era of content creation. Unlike television or professional productions, YouTube allowed anyone with a camera to share videos with the world. After its launch, YouTube quickly gained popularity. By November 2006, just over a year after Me at the Zoo was uploaded, Google acquired YouTube for $1.65 billion in stock. The platform expanded rapidly, attracting millions of users, and it became the go-to site for videos ranging from entertainment and education to vlogs and viral challenges. Today, YouTube has over 2.5 billion monthly active users and more than 500 hours of video uploaded every minute. Despite being a simple video, Me at the Zoo holds a special place in internet history. It represents the birth of online video sharing culture, paving the way for content creators, influencers, and vloggers who now dominate the digital landscape. The video itself remains one of the most watched first videos on any platform, with millions of views. From its humble beginning with Me at the Zoo, YouTube has grown into a global powerhouse, transforming entertainment, news, and education. Today, YouTube hosts everything from viral videos and documentaries to full-length movies and live broadcasts. And it all started with a short, unscripted video at a zoo, proving that sometimes the smallest moments can create the biggest revolutions.
Before becoming the beloved family classic we know today, E.T. the Extraterrestrial was originally conceived as a horror film. The idea for the movie came from legendary director Steven Spielberg, but in its earliest form, the script told a much darker and scarier story. The original concept was titled Night Skies, and it focused on hostile alien invaders terrorizing a rural family. This eerie premise was a far cry from the heartwarming tale of friendship that eventually became E.T. The story of E.T. began in the late 1970s after the success of Spielberg's sci-fi masterpiece, Close Encounters of the Third Kind. While working on the project, Spielberg became fascinated with the idea of aliens visiting Earth. Inspired by a real-life incident in which a Kentucky family claimed to have been attacked by alien creatures, Spielberg initially wanted to explore a darker version of an extraterrestrial encounter. He hired John Sayles, a screenwriter known for his work in science fiction, to develop a script titled Night Skies. The film would have featured a group of violent aliens attacking a rural farmhouse, terrifying the family inside. One of these aliens, however, would have been a gentle and kind-hearted creature, forming a bond with the family's youngest child. This character later evolved into E.T. While Spielberg found the concept of night skies intriguing, he ultimately felt that making a horror movie about aliens didn't align with his creative vision. He was more interested in telling a story of friendship and wonder, rather than fear and terror. Around this time, he also realized that the subplot involving the gentle alien bonding with a child was the most emotionally compelling part of the script. Spielberg scrapped Night Skies and instead focused on creating a more personal, heartfelt film. He worked with screenwriter Melissa Matheson, who helped transform the idea into a child-friendly adventure about a lost alien and his bond with a young boy, Elliot. This reimagining led to the birth of E.T. the Extraterrestrial, which was released in 1982 and became one of the most iconic and successful films of all time. Although Night Skies was never made, its influence can be seen in several later projects. Elements of the horror concept resurfaced in Spielberg's 2002 film Signs, which featured hostile aliens terrorizing a farmhouse. Additionally, the design of E.T. was partially inspired by Night Skies, as Spielberg had originally envisioned the film's aliens with elongated necks and large eyes. Interestingly, the idea of a group of children encountering something supernatural also played a role in inspiring Stranger Things, a show that pays tribute to E.T. and other classic 1980s sci-fi films. What started as a dark and terrifying alien invasion story evolved into one of the most touching and beloved films of all time. Had Spielberg gone forward with Night Skies, the world may have never experienced the emotional and magical journey of E.T. This shift from horror to heartfelt storytelling is a testament to Spielberg's instincts as a filmmaker, turning what could have been a terrifying alien thriller into a timeless tale of friendship and wonder.
Winnie the Pooh, the beloved honey-loving bear created by A.A. Milner, has surprisingly been banned or censored in certain places for a variety of reasons. While the stories are widely cherished for their warmth, innocence and philosophical depth, some regions have deemed the character inappropriate due to political, cultural or ideological concerns. One of the most well-known instances of Winnie the Pooh being banned is in China. The Chinese government took offence to the use of Pooh as a satirical symbol to mock President Xi Jinping. Comparisons between the bear and the Chinese leader began circulating online in the early 2010s, often highlighting similarities between Xi's appearance and the round, friendly bear. As these memes gained popularity, the government responded by censoring images and references to Winnie the Pooh on social media platforms. This ban extended beyond digital spaces, with the character being restricted in books, merchandise and even certain public appearances. Beyond political concerns, Winnie the Pooh has faced bans in other parts of the world for different reasons. In Poland and some regions in Turkey, officials have criticised the bear for not wearing pants, arguing that this makes him an inappropriate character for children. Some conservative groups have also objected to the character's supposed androgynous nature, believing it challenges traditional gender norms. Although these concerns may seem trivial to most, they have led to occasional restrictions on the use of Winnie the Pooh in educational and public settings. Despite these controversies, Winnie the Pooh remains an enduring symbol of childhood nostalgia and gentle wisdom. While certain governments and institutions may try to suppress the character, his stories continue to be treasured by fans worldwide, reminding people of the simple joys of friendship, kindness and curiosity.
The Terminator's iconic line, "I'll be back," almost took a different form during production. The 1984 sci-fi classic, directed by James Cameron and starring Arnold Schwarzenegger, cemented itself in pop culture history with this simple yet powerful phrase. However, what many don't know is that this legendary line was nearly spoken as "I'll come back," which could have drastically altered its impact. During filming, Schwarzenegger and Cameron reportedly debated over the phrasing of the line. Schwarzenegger, who was still perfecting his English at the time, found "I'll be back" somewhat unnatural to say, and he suggested "I will come back" instead, believing it sounded more robotic and fitting for the character of the Terminator. Cameron, however, insisted on keeping the line as written, arguing that "I'll be back" had a smoother and more memorable rhythm. He also emphasized that the shorter phrase sounded more natural in conversation and would likely have a stronger impact on audiences. In hindsight, Cameron's decision proved to be the right one. When "I'll be back" was delivered in Schwarzenegger's deep, monotone voice, it became an instantly unforgettable moment in cinematic history. The line was later repeated in various forms throughout the Terminator franchise, and has been frequently referenced in pop culture, from movies and TV shows to political speeches and everyday conversations. It is now considered one of the greatest movie quotes of all time, even ranking on the American Film Institute's list of top movie quotes. Had the line been altered to "I'll come back," it might not have carried the same weight or cultural resonance. The power of "I'll be back" lies in its brevity and simplicity, making it a perfect example of how even minor script changes can influence the lasting legacy of a film.
The Titanic's distress signal is a key moment in maritime history because it marked one of the first high-profile uses of the SOS signal, helping to establish it as the international standard. Before SOS, ships primarily relied on CQD, a distress call created by the Marconi Company in 1904. The meaning of CQD has been debated. Some say it stood for "Come Quick Danger," while others claim it simply meant general call, distress, with the letters themselves not standing for specific words. Regardless of its exact meaning, CQD was the widely recognized emergency call among ships using Marconi wireless equipment, which included the Titanic. However, by 1908, international maritime authorities had agreed on SOS as the new standard distress signal. The main reason for this change was that SOS, 3 short, 3 long, 3 short in Morse code, was much easier to recognize than CQD, especially in poor radio conditions or when signals were faint. Unlike CQD, which could sometimes be mistaken for other transmissions, SOS was simple, unmistakable, and easy to transmit quickly. Despite this, many ships, particularly British ones operating under the Marconi system, still use CQD out of habit, and the transition to SOS was slow. When the Titanic struck an iceberg late on the night of April 14, 1912, and began taking on water, senior wireless operator Jack Phillips initially transmitted CQD as the distress signal. He repeatedly sent out messages such as CQD, 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 MGY, the Titanic's call sign, we have struck an iceberg, sinking fast, come to our assistance. Junior operator Harold Bride, who was assisting Phillips, then suggested they also try SOS, remarking that it was a new signal and that it might be their last chance to use it. Phillips then alternated between sending CQD and SOS, hoping to increase the chances of their message being received. The distress signals were eventually picked up by the RMS Carpathia, a passenger liner about 58 miles away. Upon receiving the call, the Carpathia immediately changed course and raced toward the Titanic's last known position, navigating dangerous ice fields in the dark. Unfortunately, despite traveling at full speed, the Carpathia took over 3 hours to reach the site, arriving long after the Titanic had sunk. By the time rescuers arrived, more than 1,500 people had perished, with only around 700 survivors in lifeboats. Although the Titanic was not the absolute first ship to use SOS, its use of the signal in such a high-profile disaster helped cement SOS as the universally recognized distress call. In the wake of the tragedy, maritime safety regulations were significantly improved. The disaster led to the establishment of the Radio Act of 1912, which required 24-hour radio watch on passenger ships, ensuring that distress signals would not go unanswered. It also contributed to the creation of the International Ice Patrol and improvements in lifeboat regulations. The Titanic's distress signals remain one of the most poignant aspects of the disaster, symbolizing both the desperate attempts to call for help and the tragic inefficiencies of early 20th century maritime communication. Today, SOS is universally recognized as a distress signal used in emergencies far beyond maritime settings, including aviation and even general survival situations. The Titanic played a crucial role in the adoption and widespread recognition of SOS, ensuring that future distress calls would be clearer, faster, and more effective in saving lives.
Michael Jackson, the king of pop, had a well-documented fascination with comic books. And at one point, he even attempted to buy Marvel Comics in order to fulfill his dream of playing Spider-Man. This lesser-known chapter of Jackson's life highlights his deep love for superheroes and his ambition to expand his career beyond music and into film. During the 1990s, Marvel Comics was struggling financially and was on the verge of bankruptcy. Seeing an opportunity, Michael Jackson reportedly explored the idea of purchasing the company. His main motivation? He wanted to secure the rights to Spider-Man so that he could portray the iconic superhero in a movie. Jackson was a huge fan of the character and saw himself as a natural fit for the role. He even approached legendary comic book creator Stan Lee about his ambitions, discussing the possibility of acquiring Marvel to make his Spider-Man dreams a reality. Stan Lee, the co-creator of Spider-Man and other Marvel superheroes, later confirmed in interviews that Jackson had seriously considered the purchase. According to Lee, Jackson was very passionate about the idea and saw it as a way to break into Hollywood in a major way. However, the deal never came to fruition, and Marvel ultimately survived its financial troubles, later being bought by Disney in 2009 for $4 billion. Despite failing to acquire Marvel, Jackson still pursued his Hollywood aspirations in other ways. He had previously starred in films like Moonwalker in 1988 and had even auditioned for the role of Professor X in X-Men in 2000, though he was ultimately passed over for Patrick Stewart. While his dream of becoming Spider-Man never materialized, his attempt to buy Marvel remains a fascinating what-if scenario in both comic book and entertainment history. Had Jackson succeeded in his bid to buy Marvel, it's intriguing to imagine how the superhero film landscape might have changed. His version of Spider-Man would likely have been vastly different from the ones portrayed by Tobey Maguire, Andrew Garfield or Tom Holland. While the idea may sound unusual today, it speaks to Jackson's boundless ambition and his willingness to think outside the box in pursuit of his creative passions.
One of the most iconic visual elements of The Matrix, released in 1999, is its cascading green digital rain, streams of glowing green characters that represent the simulated reality of The Matrix itself. This distinctive code, which has become synonymous with the film and its cyberpunk aesthetic, has an amusing and unexpected origin. It is actually made up of Japanese sushi recipes. Simon Whiteley, a production designer for The Matrix, revealed in an interview that he was responsible for creating the famous green code. To achieve the look, he scanned characters from a Japanese cookbook that belonged to his wife. The text primarily consisted of katakana, hiragana, and kanji characters, many of which were part of sushi recipes. Whiteley then manipulated the characters digitally, arranging them into the mesmerizing streams of green symbols that became the visual representation of the Matrix's programming. This revelation adds an ironic and humorous twist to the film's deep philosophical themes about reality, simulation, and artificial intelligence. While audiences might have assumed the Matrix code was composed of complex algorithms or hidden messages, it is in reality a simple aesthetic effect derived from everyday Japanese cooking instructions. The digital rain effect became one of the most recognizable elements of the Matrix franchise, used in sequels, spin-offs, and marketing materials. It has since been widely referenced and parodied in pop culture, further cementing its status as one of the most memorable images in cinematic history. The fact that its origins lie in something as ordinary as sushi recipes only adds to the film's mystique and charm, showing how creative inspiration can come from the most unexpected places.
Keanu Reeves is widely known for his generosity, and one of the most remarkable examples of this was his decision to give away a significant portion of his earnings from the Matrix films to the crew members who worked behind the scenes. While Reeves made a substantial salary from the trilogy, he prioritized ensuring that the people responsible for bringing the films to life, particularly the special effects and costume teams, were properly rewarded for their efforts. Reeves reportedly gave away tens of millions of dollars from his Matrix earnings, particularly his back-end profits from the sequels. Some reports suggest that he forfeited nearly $75 million of his potential earnings, allowing it to be distributed among the visual effects and costume departments. His reasoning was that these crews were the true unsung heroes of the films, working tirelessly to create the groundbreaking visual effects and futuristic aesthetics that made The Matrix a cinematic revolution. Reeves believed that without their expertise, the movie's success would not have been possible, and he wanted them to share in the financial rewards. In addition to this extraordinary act of generosity, Reeves is also known for treating stunt performers with great respect. During the Matrix films, he gifted Harley-Davidson motorcycles to several stunt crew members as a token of appreciation for their hard work. He has repeated similar gestures in other films, such as buying Rolex watches for the stunt team on John Wick 4. These acts have only added to Reeves's reputation as one of the most humble and kind-hearted actors in Hollywood. Keanu Reeves' willingness to share his wealth, especially with the crew members who typically go unnoticed, has cemented his legacy not just as an action star, but as one of the most genuinely kind figures in the entertainment industry. While many actors negotiate for larger paychecks, Reeves has repeatedly shown that his priorities go beyond money, focusing instead on gratitude, fairness, and uplifting those around him. His generosity remains one of the many reasons why he is so beloved by fans and respected by his colleagues.
A group of crows is famously called a murder, a term that has fascinated and intrigued people for centuries. Unlike more straightforward collective nouns like a flock or herd, murder carries a dark and mysterious connotation that perfectly suits these intelligent and often misunderstood birds. The origin of this term dates back to the late Middle Ages, when poetic and dramatic names were given to groups of animals. These names, known as terms of venery or nouns of assembly, often reflected popular beliefs or characteristics associated with the species. The word murder likely arose from the long-standing association between crows and death. In medieval Europe, crows and their relatives, such as ravens, were often seen scavenging battlefields, gallows and graveyards, reinforcing their eerie reputation. Their black feathers, sharp calls, and habit of gathering in large numbers contributed to the perception of them as ominous creatures. Folklore and superstition further fueled this image, with some cultures believing that crows were harbingers of death or messengers from the spirit world. Despite their grim reputation, crows are among the most intelligent birds on the planet. Studies have shown that they possess remarkable problem-solving abilities, tool usage, and even facial recognition skills. They can remember human faces, hold grudges, and teach their knowledge to other crows, demonstrating a level of social intelligence rarely seen in birds. Their ability to work together and warn each other of danger is another reason why they often gather in large numbers, forming what we call a murder. While the term murder of crows may sound ominous, it is mostly used in a poetic or humorous sense today. In reality, crows are highly social birds that rely on their group dynamics for survival. Their gatherings, while sometimes noisy and chaotic, are essential for communication, protection, and finding food. Whether seen as eerie omens or simply as clever birds, crows continue to captivate human imagination, living up to their legendary and mysterious name. It may come as a surprise, but there are actually more public libraries in the United States than McDonald's restaurants. While McDonald's is one of the most recognizable fast food chains in the world, with thousands of locations across the country, public libraries quietly outnumber them, demonstrating the enduring value of free access to knowledge and community resources. As of recent counts, there are around 17,000 public libraries in the US, compared to approximately 13,500 McDonald's locations. This number includes both main library branches and smaller community branches, showing how widespread and accessible libraries are across the country. Despite the fast food industry's dominance in American culture, libraries have maintained a strong presence, continuing to serve as vital centers for education, research, and public programs. Public libraries offer much more than just books. They provide free internet access, job search assistance, literacy programs, and even social services, making them an essential resource for many communities. Libraries play a particularly important role in rural and underserved areas where access to technology and educational materials might be limited. Unlike McDonald's, which focuses on convenience and quick meals, libraries prioritize lifelong learning and community engagement, showing a different kind of investment in the well-being of American society. The fact that libraries outnumber McDonald's also highlights the resilience of public institutions in an era dominated by digital media. While some have speculated that libraries might become obsolete due to the rise of e-books and the internet, their continued presence proves that they are still highly valued. People still turn to libraries for quiet study spaces, book recommendations, and access to free educational resources that fast food chains, no matter how widespread, simply cannot provide. This statistic is a testament to the power of knowledge and the enduring importance of libraries in the modern world.
Despite being commonly associated with Chinese cuisine, fortune cookies were actually invented in the United States, not China. While they are a staple at Chinese restaurants across America, most people in China are unfamiliar with them, and they are rarely found in traditional Chinese culture or cuisine. Their true origins can be traced back to Japanese American communities in California during the early 20th century. The invention of the fortune cookie is widely debated, but it is generally believed to have originated in San Francisco or Los Angeles in the early 1900s. One theory credits a Japanese immigrant named Makoto Hagiwara, who ran the Japanese tea garden in San Francisco's Golden Gate Park. Hagiwara is said to have introduced a version of the cookie in the 1910s, based on a traditional Japanese cracker called Sujura Senbei, which contained small paper fortunes. These cookies were slightly larger, less sweet, and made with sesame oil rather than butter or vanilla. Another claim comes from Los Angeles, where a Chinese-American businessman named David Jung, the founder of the Hong Kong Noodle Company, reportedly invented the fortune cookie around the same time. According to this story, Jung created the cookies in 1918 and distributed them for free to the poor, each one containing an uplifting message of encouragement. While both claims have merit, it was ultimately the San Francisco versus Los Angeles fortune cookie war that led to a court ruling in 1983, deciding that the modern fortune cookie was first popularized in San Francisco. After their invention, fortune cookies became a popular addition to Chinese-American restaurants, particularly after World War II, when they were mass-produced and marketed as a fun, exotic treat. The cookies' association with Chinese cuisine likely came from the growing number of Chinese restaurants in the United States that adapted them as a way to entertain and engage customers. However, in China, fortune cookies remain largely unknown, and visitors who expect to find them in Chinese restaurants abroad are often surprised when they don't. The fortune cookie's American origins highlight how cultures blend and evolve, creating new traditions that become widely accepted. Though they may not be authentically Chinese, fortune cookies have become an iconic part of the Chinese-American dining experience, serving as a symbol of good luck and a fun way to end a meal.
Many people use the phrase in a jiffy to mean very quickly, but few realize that a jiffy is an actual scientific unit of time. In scientific terms, a jiffy typically refers to 1/100th of a second or 10 milliseconds, though its exact definition can vary depending on the field of study. The term was first coined by physical chemist Gilbert Newton Lewis in the early 20th century. Lewis used jiffy to describe the amount of time it takes for light to travel 1 centimeter in a vacuum, which is approximately 33.3 picoseconds or trillionths of a second. However, the term has since been adapted for different scientific contexts, leading to multiple definitions. In electronics and computing, a jiffy is often defined as the length of one cycle of an alternating current power supply. In the United States, where the AC frequency is 60 Hz, a jiffy is 1/60th of a second, while in regions with 50 Hz power supplies, a jiffy is 1/50th of a second. In computer science, a jiffy is sometimes used to refer to the time between system clock ticks, which can vary depending on the hardware and software. Despite its precise scientific uses, jiffy is most commonly used in everyday language as a casual way to describe something happening quickly. However, knowing that a jiffy has a real, measurable meaning adds an interesting twist to the phrase. Whether in physics, computing, or casual speech, a jiffy remains a small yet fascinating unit of time.
It may seem ironic, but Thomas Edison, the inventor of the light bulb, was reportedly afraid of the dark. While there is no definitive proof of this claim, stories and anecdotes suggest that Edison had an aversion to darkness, which some speculate may have influenced his relentless pursuit of electric lighting. Given his lifelong dedication to innovation and his numerous experiments with electricity, the idea that he sought to conquer his own fear with one of his greatest inventions is an intriguing possibility. Edison was a prolific inventor, holding over 1,000 patents, and his development of the practical incandescent light bulb in the late 19th century revolutionized the way people lived. Before the widespread use of electric light, people relied on candles, oil lamps and gas lighting, which were often dim, expensive and hazardous. Edison's light bulb provided a safer, more reliable alternative, extending the hours in which people could work and socialize. His invention played a crucial role in modernizing cities and homes, eliminating the need for darkness in many aspects of daily life. The idea that Edison feared the dark aligns with his well-documented obsession with sleep and productivity. He was known for his irregular sleep habits, often taking short naps instead of sleeping through the night. Some accounts suggest that he preferred to sleep in brightly lit rooms and kept multiple light sources around him at all times. Whether this behavior stemmed from a genuine fear of darkness or simply his love for artificial light remains a mystery. While the claim about Edison's fear of the dark is difficult to verify, it adds an interesting layer to his legacy. Whether or not his fear directly influenced his inventions, his contributions to electric lighting undeniably changed the world, making darkness far less of an obstacle in everyday life. If the story is true, it would be a fitting example of how personal challenges can inspire some of the greatest technological advancements in history.
Off the coast of Japan, there is a small mysterious island known as Okunoshima, often referred to as Rabbit Island because it is inhabited almost exclusively by hundreds of wild rabbits. This island, located in the inland sea of Japan in Hiroshima Prefecture, has become a popular tourist destination for animal lovers who visit to interact with the friendly, free-roaming bunnies. However, despite its now adorable reputation, Okunoshima has a much darker history. During World War II, Okunoshima was used as a secret chemical weapons testing facility by the Japanese Imperial Army. The island housed a factory that produced poisonous gases, including mustard gas, which was used in warfare. Because of the dangerous nature of the experiments conducted there, the island was erased from official maps to keep its existence hidden from the public. After the war ended, the chemical plant was abandoned and efforts were made to decontaminate the area. The exact origin of the rabbit population remains uncertain, but there are two main theories. One theory suggests that the rabbits were originally test subjects for the chemical experiments, and when the factory was shut down, they were either released or escaped. However, there is no solid evidence to support this claim, as it is believed that any test animals would not have survived the exposure to toxic substances. The more widely accepted theory is that rabbits were introduced to the island by tourists in the 1970s, and without any natural predators, their population quickly grew. Today, the island is completely safe for visitors, and the Okunoshima Poison Gas Museum serves as a reminder of its wartime past. Despite its dark history, the island has transformed into a peaceful wildlife sanctuary, attracting thousands of tourists who come to feed and play with the rabbits. Hunting and bringing predators to the island are strictly prohibited to protect the rabbit population, making it a true paradise for these animals. Okunoshima is a fascinating example of how a place can be repurposed over time, turning from a site of war into a unique and heartwarming attraction. Whether you visit for the historical significance or the adorable bunnies, Rabbit Island remains one of Japan's most unusual and enchanting destinations.
The most expensive book ever sold is Leonardo da Vinci's Codex Leicester, which was purchased for $30.8 million in 1994 by Bill Gates, the co-founder of Microsoft. This rare manuscript, written by Da Vinci in the early 16th century, is a collection of scientific writings, sketches and observations, reflecting the Renaissance genius's insatiable curiosity about the natural world. The Codex Leicester consists of 72 pages filled with Da Vinci's handwritten notes and illustrations, written in his distinctive mirror script, a technique where he wrote from right to left, requiring a mirror to read the text. The notebook primarily explores water, astronomy, geology and light, including theories about the movement of water, the reflection of the moon's light, and even ideas that foreshadowed modern scientific discoveries. The Codex Leicester offers a fascinating glimpse into Da Vinci's mind, with pages dedicated to topics as varied as the properties of fossils, the formation of mountains, and the luminosity of the moon. Each page is a testament to his relentless pursuit of knowledge and his ability to see connections between seemingly unrelated phenomena. It's, a true masterpiece of scientific thought and artistic expression. Originally compiled between 1506 and 1510, the Codex changed hands multiple times before becoming the most expensive book in history. It was named after Thomas Coke, the Earl of Leicester, who acquired it in 1717. The manuscript remained in his family's possession for over 250 years until it was sold in 1980 to wealthy businessman Armand Hammer, who briefly renamed it the Codex Hammer. After Hammer's death, the manuscript was auctioned in 1994, with Bill Gates emerging as the winning bidder. Since acquiring the Codex, Gates has digitized its pages and allowed portions of it to be displayed in museums worldwide, ensuring that Leonardo da Vinci's insights are accessible to the public. The manuscript remains an invaluable piece of history, showcasing the boundless intellect of one of the greatest minds of all time. Its record-breaking price reflects not only its rarity, but also the immense value placed on da Vinci's contributions to art, science, and human knowledge.
In Japan, some traffic lights appear blue instead of green, a unique phenomenon that can be traced back to both linguistic history and government regulations. While the lights function just like standard green traffic signals elsewhere, their distinct bluish tint is the result of an unusual intersection between language and law. The reason behind Japan's blue-appearing traffic lights originates from the way colors are historically classified in the Japanese language. Traditionally, Japanese had only 4 primary color terms: black, kuro, white, shiro, red, aka, and blue, ao. For centuries, the word ao-ching was used to describe a broad range of colors, including shades that would be considered green in modern English. Over time, a distinct word for green, midori, lu, emerged, but even today, some green things in Japan are still referred to as ao. For example, green apples, green vegetables, and even traffic signals are often described as AO instead of Midori, reflecting this historical color classification. Japan originally followed international traffic signal standards using clearly green lights. However, because the Japanese language continued to refer to them as AO, there was pressure to make the lights appear as blue as possible while still being legally green. In 1973, the Japanese government responded by modifying traffic light standards to allow the bluest possible shade of green that would still meet international regulations. As a result, some traffic signals in Japan have a noticeably bluish-green hue, making them appear distinctly blue compared to the bright green traffic lights seen in other countries. While not all Japanese traffic lights appear blue, many in certain regions or newer installations use this blue-green tint. To a foreign visitor, it might seem like Japan has blue traffic lights, but technically they are still classified as green. This unusual phenomenon is a perfect example of how language and culture can influence even everyday infrastructure like traffic signals.
In Iceland, there is a one-of-a-kind library known as the Library of Rejected Manuscripts, a sanctuary for literary works that were turned down by publishers. Located in the small town of Flateyri, this library was created as a response to the often harsh realities of the publishing industry, giving rejected authors a second chance to have their work preserved and appreciated. The library was founded by Icelandic publisher Elias Snæland Jonsson, with the belief that rejection does not necessarily mean a book lacks value. Many famous works throughout history were initially rejected before eventually becoming classics. So this library serves as a place where failed attempts can still find an audience. By collecting manuscripts that were denied by publishers, it allows authors to share their stories even if traditional publishing routes closed their doors. Iceland has a deep literary tradition, with one of the highest book publishing rates per capita in the world. The country's love for books is so strong that it has an annual tradition called Jólabókaflóðið, or the Christmas book flood, where people give and receive books as gifts during the holiday season. However, despite this thriving literary culture, not all aspiring authors get published, which is where the Library of Rejected Manuscripts comes in. The library accepts manuscripts from any genre and any country, so long as they have been rejected by at least one publisher. Some of these books might never reach mainstream readers, but they still have a home where they can be read, studied, and appreciated by visitors. It serves as a reminder that rejection is not the end of creativity. Many great authors, including J.K. Rowling and Stephen King, faced multiple rejections before their works became successful. For writers, the library of rejected manuscripts is not just a collection of failed works, but a symbol of perseverance. It encourages authors to keep writing, keep submitting, and keep believing in their ideas. Some of the rejected books stored here may one day find new life, be revised, or even be rediscovered as hidden gems. This Icelandic library stands as proof that every story deserves a place, even if it doesn't fit the traditional mold of publishing success.
The Eiffel Tower, one of the most iconic landmarks in the world, has a secret apartment at its top that was once used by its designer, Gustave Eiffel. Hidden away from public view, this small yet cosy space was a private retreat where Eiffel could work, reflect and entertain special guests, including some of the most famous figures of his time. When designing the Eiffel Tower in the late 19th century, Gustave Eiffel included a private apartment near the top at about 1,000 feet, or 300 meters, above the ground. Unlike the cold industrial structure of the tower itself, this apartment was designed with warm wooden furniture, patterned wallpaper, and a piano, giving it a surprisingly homey feel. It also had a laboratory where Eiffel conducted scientific experiments related to astronomy, physics, and meteorology. The existence of Eiffel's secret apartment became widely known shortly after the tower was completed in 1889, and it quickly became the subject of public fascination. Many wealthy Parisians and influential figures offered large sums of money to rent or stay in the space. But Eiffel refused every request. He preferred to keep it as his own private retreat, using it to host important guests, including Thomas Edison, who famously visited the apartment and gifted Eiffel a phonograph as a token of appreciation. While some believe Eiffel designed the apartment purely for personal use, others suggest it was meant to demonstrate the tower's potential for scientific research. At the time, the Eiffel Tower was not just a landmark, but a cutting-edge engineering project, and Eiffel used the space to conduct experiments with radio signals, wind resistance, and atmospheric pressure. His work in the apartment ultimately helped pave the way for modern telecommunications and meteorology. For many years, Eiffel's private space remained closed to the public. However, today, visitors can catch a glimpse of the apartment through a small viewing window, where mannequins of Eiffel and Edison are displayed inside. Though small and simple, the apartment remains a fascinating piece of history, revealing a more personal side of the man who forever changed the Parisian skyline. Gustave Eiffel's secret apartment is a hidden treasure within one of the world's most famous monuments, offering insight into the mind of a visionary who not only built an engineering marvel, but also found a way to enjoy it from the best seat in Paris.
Time zones create an interesting quirk in the way we experience time, making it possible for someone to celebrate their birthday twice in one day. The Earth is divided into 24 time zones, each generally 1 hour apart, though some have half-hour or even 45-minute differences. Because of this, different parts of the world experience the same calendar date at different times. This means that if a person were to travel backward across time zones after celebrating their birthday in one location, they could reach another place where their birthday is still ongoing. For example, imagine someone celebrating their birthday in Japan, which is ahead of many countries in terms of time. If they then boarded a flight to Hawaii, which is many hours behind, they would land in a place where their birthday is still happening according to the local time. This allows them to extend their celebrations and, in a way, relive part of their special day. This phenomenon isn't just limited to birthdays, it applies to any significant event based on dates, including New Year's celebrations. Some travelers even plan trips specifically to take advantage of this time zone trick, ensuring they get extra hours to enjoy their big day. It's a fun and unique way to bend time, at least from a human perspective, and make the most of a special occasion.
The word alphabet has its roots in the Greek language, specifically from the first two letters of the Greek alphabet, alpha and beta. The term alphabet itself is a combination of these two names, reflecting the fundamental building blocks of written language. This connection highlights the deep influence of ancient Greek on modern linguistic concepts, especially in the development of writing systems. The Greek alphabet, which dates back to around the 8th century BCE, was adapted from the earlier Phoenician script. The Phoenicians, a seafaring civilization in the Mediterranean, used a consonant-based writing system which the Greeks modified by adding vowels, creating one of the first true alphabets. This system greatly influenced the Latin alphabet, which is the basis for English and many other languages today. The impact of the Greek alphabet goes beyond just the word alphabet. Many modern terms, especially in science and mathematics, still use Greek letters such as pi in mathematics or omega in physics. The influence of this writing system has shaped the way languages are written and structured, making it a foundational part of global communication.
Unlike the other planets in our solar system, Earth is the only one that is not named after a god from mythology. The names of the other planets, Mercury, Venus, Mars, Jupiter, Saturn, Uranus and Neptune, are all derived from Roman deities, reflecting the influence of ancient Roman and Greek culture on astronomy. For example, Mars is named after the Roman god of war due to its reddish, blood-like appearance, and Jupiter, the largest planet, is named after the king of the Roman gods. The name Earth comes from Old English and Germanic origins, rather than mythology. The Old English word Eorda and its Germanic counterpart Erda both meant ground or soil. Unlike the other planets, which were named by ancient astronomers who studied them as celestial bodies, Earth was historically seen more as the land people lived on rather than a planet in space. Since early civilizations didn't initially recognize Earth as a planet like the others, it never received a name based on a god or deity. It wasn't until later scientific advancements that Earth was fully understood as a planet in its own right, orbiting the Sun just like the others. By that time, the name Earth was already deeply rooted in language and culture, and no mythological renaming occurred. This makes Earth unique not only in its ability to sustain life, but also in its name, which connects it more to the ground beneath our feet than to the divine figures of ancient mythology.
Light, while famously fast, does not always travel at the same speed. In a vacuum such as space, light moves at approximately 299,792,458 meters per second. This is considered the universal speed limit. However, when light enters a different medium such as water, its speed slows down by about 25% due to a phenomenon known as refraction. This slowing occurs because water is denser than a vacuum or air. As light waves pass through water molecules, they interact with the particles, causing the waves to scatter and effectively slow down. In water, light travels at roughly 225 million meters per second, which is significantly slower than in air or space. This effect is what causes objects to appear distorted or bent when viewed underwater, a classic example of refraction. The slowing of light in water has important real-world implications. For example, it affects underwater optics, meaning that divers and marine life experience a different perception of light and color. It also plays a crucial role in fiber optic communications, where light signals are transmitted through glass or water-based mediums, and understanding how light slows down helps optimize data transmission. Interestingly, different materials slow light down by varying amounts. Diamond, for example, slows light down even more than water, reducing its speed by nearly 60%. This property is one reason diamonds have their signature sparkle. Light bends and reflects internally before exiting. The fact that light isn't a constant speed everywhere, but rather changes depending on the medium it's traveling through, is a key principle in physics, helping scientists better understand the behavior of light and energy.
The idea that another Earth-like planet could exist somewhere in the universe isn't just science fiction. It's supported by mathematical probability and astrophysical observations. Given the vastness of the cosmos, with hundreds of billions of galaxies, each containing hundreds of billions of stars, the chances of another planet similar to Earth existing are statistically quite high. Scientists estimate that there could be trillions of planets in the observable universe, making it likely that some of them have conditions similar to those of Earth. One of the key factors in finding another Earth-like planet is the Goldilocks zone, or habitable zone, which refers to the region around a star where conditions are just right for liquid water to exist. Since liquid water is essential for life as we know it, planets in this zone have a higher chance of supporting life. According to NASA's Kepler Space Telescope data, there are potentially billions of exoplanets, or planets outside our solar system, in habitable zones, some of which are Earth-sized and orbit stars similar to our Sun. Mathematically, scientists use the Drake equation, a formula that estimates the number of civilizations in our galaxy, by considering factors like the rate of star formation, the fraction of stars with planets, and the probability of life developing. While the equation doesn't give an exact number, it suggests that Earth-like planets capable of supporting life may not be rare. Additionally, astronomers have already discovered promising candidates such as Kepler 452b, Proxima Centauri b, and TOI 700d, which are located in their respective habitable zones and have characteristics somewhat similar to Earth. However, confirming whether these planets truly resemble Earth in terms of atmosphere, water presence, and life-supporting conditions requires further study with advanced telescopes like the James Webb Space Telescope, or JWST. In summary, while we haven't yet found an exact replica of Earth, mathematics and probability strongly suggest that such a planet exists somewhere in the universe. With continuous advancements in space exploration, the discovery of a true Earth twin may just be a matter of time.
The small dot above the lowercase letter I, and also the letter J, is called a tittle. This tiny mark may seem insignificant, but it plays an important role in typography and language. The word tittle comes from the Latin word titulus, meaning inscription or heading. Over time, it evolved into a term for small marks or strokes in writing. The tittle helps differentiate lowercase I and J from similar-looking letters, especially in handwritten or cursive scripts. Without it, these letters could easily be mistaken for L or other characters, causing confusion in reading and writing. The introduction of the tittle made texts clearer and more legible, especially as writing styles evolved over centuries. Historically, not all alphabets or writing systems included a tittle. In early Latin and medieval manuscripts, scribes often wrote I without a dot, especially when it appeared next to tall letters like M or N. The dot became more standardized with the development of the printing press and modern typography, ensuring consistent and readable text. Beyond its practical function, the tittle has also found its way into language and culture. The phrase to dot your I's and cross your T's means paying close attention to detail, emphasizing the importance of even the smallest marks in writing. While often overlooked, the humble tittle is a small but essential part of written language, helping maintain clarity and distinction in words.
Lightning is one of nature's most powerful and frequent phenomena, striking Earth approximately 8 million times every day, which translates to about 100 lightning bolts per second worldwide. This incredible frequency occurs because thunderstorms are constantly forming across different regions of the planet, especially in areas with warm, humid air, where atmospheric conditions are ideal for electrical discharge. Lightning forms when static electricity builds up in storm clouds due to the collision of ice particles and water droplets. This creates a charge imbalance, with negatively charged particles accumulating at the bottom of the cloud and positive charges forming on the ground. When the charge difference becomes large enough, a sudden electrical discharge occurs, resulting in a lightning bolt that can travel at speeds of 270,000 miles per hour and reach temperatures hotter than the surface of the Sun, up to 30,000 Kelvin. While lightning can occur anywhere in the world, some locations experience far more strikes than others. Lake Maracaibo in Venezuela holds the record for the most lightning activity, with storms occurring more than 260 nights a year. Similarly, regions near the equator, such as Central Africa and Southeast Asia, see frequent lightning due to their warm, moist climates. Lightning is not just a spectacular natural event, it also has significant impacts on the environment and human life. It can ignite wildfires, cause power outages, and even pose a risk to people and buildings. However, it also plays an important role in nature by helping to produce nitrogen oxides, which contribute to the nitrogen cycle, enriching soil fertility. With advanced meteorology and lightning detection systems, scientists can now track lightning activity in real time, helping to predict severe weather and reduce risks. Despite its dangers, lightning remains a fascinating and essential part of Earth's natural processes, shaping the planet in ways both seen and unseen.
Email has become one of the most dominant forms of communication in the digital age, with a staggering 240 million emails sent every minute worldwide. This number highlights just how central email is to modern life, whether for personal messages, business communications, marketing, or even spam. With billions of people using email daily, it remains a crucial tool for staying connected in both professional and personal settings. The rapid rate of email transmission is made possible by the vast network of servers and internet infrastructure that supports digital communication. Emails travel almost instantaneously through data centers and cloud-based systems, ensuring that messages reach their recipients in seconds. Popular email services like Gmail, Outlook, and Yahoo Mail handle a significant portion of this massive email traffic. However, not all emails are meaningful human interactions. A large percentage of emails sent every minute consist of spam, promotional messages, and automated notifications. In fact, spam accounts for over 45% of all email traffic, making cybersecurity and spam filters essential for protecting inboxes from phishing scams, malware, and other threats. The sheer volume of emails also raises concerns about data storage and environmental impact. Large-scale email servers require immense amounts of energy to operate, contributing to the overall carbon footprint of the internet. Simple actions like reducing unnecessary emails, unsubscribing from mailing lists, and deleting old messages can help minimize digital waste. Despite competition from instant messaging apps and social media, email continues to thrive as a primary form of communication. Its reliability, formal structure, and ability to send attachments make it indispensable for businesses, education, and official correspondence. With billions of users worldwide, email remains a cornerstone of the digital world, evolving alongside technology to meet the demands of an increasingly connected society.
The idea that folding a piece of paper 42 times would allow it to reach the moon sounds impossible at first, but it's a fascinating example of exponential growth in action. The reason behind this mind-blowing fact lies in how paper thickness doubles with each fold. Even though a standard sheet of paper is only about 0.1 millimeters thick, repeated folding causes its height to grow at an astonishing rate. Each time you fold the paper, its thickness doubles. After one fold, it's 0.2 millimeters thick. After two folds, it's 0.4 millimeters thick. After 10 folds, it's about 10 centimeters or 4 inches thick. After 20 folds, it reaches 10 kilometers or 6.2 miles, already higher than Mount Everest. By 42 folds, the paper's thickness surpasses 384,400 kilometers or 238,855 miles, the average distance from Earth to the Moon. This mind-bending concept is a perfect demonstration of exponential growth, where numbers increase at an accelerating rate rather than linearly. It's the same principle behind rapid population growth, compound interest, and even the way viruses spread. However, in reality, folding a piece of paper 42 times is nearly impossible due to physical limitations. Standard paper quickly becomes too thick and rigid to fold beyond 7 or 8 times, even with large sheets. The current world record for physically folding paper is 12 times, achieved with a giant sheet of ultra-thin material. Despite these real-world limitations, the math behind it is absolutely correct. This thought experiment serves as an incredible way to visualize how quickly numbers grow exponentially and helps us appreciate the surprising power of mathematics in understanding the universe.
In today's digital age, photography is more accessible than ever, and the number of pictures we take is staggering. Every 2 minutes, people around the world take more photos than all of humanity did throughout the entire 19th century. a fact that highlights just how drastically technology has changed the way we capture and preserve memories. During the 19th century, photography was a new and rare innovation. The first permanent photograph was taken in 1826 by Joseph Nicephore Nips, using a method called heliography. Early cameras were bulky, required long exposure times, and used complex chemical processes. As a result, taking photographs was expensive, time-consuming, and limited to professionals or the wealthy. By the late 1800s, with the invention of George Eastman's Kodak camera, photography became more accessible, but it was still nowhere near today's levels. Historians estimate that the total number of photos taken in the 19th century was in the millions, a tiny fraction compared to modern photography. Fast forward to today, and smartphones have completely revolutionized photography. With billions of people carrying high-quality cameras in their pockets, taking pictures has become instant, effortless, and free. Apps like Instagram, Snapchat, and TikTok encourage people to snap and share photos constantly. It's estimated that more than 1.8 trillion photos are taken each year, averaging about 5 billion photos per day. In just 2 minutes, we now capture more images than the entire 19th century combined. This explosion of photography has changed everything, from how we document history to how we interact with the world. While early photographs were rare and precious, today's images are often fleeting, stored in digital formats, and sometimes forgotten in vast online archives. The ease of taking pictures has made photography a part of daily life. But it also raises questions about privacy, digital clutter, and the value of an image in a world where pictures are endless. Nonetheless, the fact that we now take more photos in 2 minutes than in an entire century is a testament to how far technology has come. From a single blurry image in 1826 to billions of high-resolution selfies every day, photography has evolved into a universal language that shapes our culture, memories, and storytelling in ways the pioneers of the 19th century could never have imagined.
Thank you for watching. We hope these mind-blowing facts left you amazed and inspired. Don't forget to like, subscribe, and hit that notification bell because there's plenty more where that came from. Stay curious, and we'll see you in the next one.